2 kilometers north of the bent pyramid, the pyramid that failed, the pyramid that bent, the pyramid that taught the greatest builders of the ancient world the most expensive engineering lesson in human history. There stands another pyramid. This one does not bend. This one does not change its angle partway up. This one rises from the desert floor at a consistent slope of roughly 43 degrees, maintaining that angle from base to apex, without interruption, without modification, without any visible sign of the crisis or the compromise that defined its predecessor. This pyramid is smooth. This pyramid is complete. This pyramid is the first true pyramid in human history, the first structure to achieve the geometric form that we associate with the word pyramid, the form of four smooth, unbroken triangular faces meeting at a single apex high above the desert. This is the Red Pyramid of Dahshur, named for the reddish hue of the exposed limestone core blocks that give the structure its distinctive color in the afternoon light. The pyramid was built for Sneferu, the same pharaoh who built the bent pyramid, the same king whose building program had already produced two partially successful pyramids, and who was determined, with the persistence and the resources that only the most powerful ruler in the ancient world could command, to get it right. And he got it right. The Red Pyramid is the proof. It is the structure that demonstrates, in the most concrete and most permanent way possible, that the lessons of the Meidum collapse and the bent pyramid's crisis had been learned, that the knowledge gained from failure had been successfully translated into design, and that the Egyptian builders were now capable of constructing a true pyramid of monumental scale without structural crisis, without emergency repairs, without any of the improvisations and compromises that had characterized their earlier attempts. The Red Pyramid is the vindication, the structure that justified the expense, the effort, the setbacks, and the years of experimentation that Sneferu's building program had required. The numbers are striking. The Red Pyramid stands roughly 104 meters tall, the third tallest pyramid in Egypt, after the Great Pyramid and the Pyramid of Khafre at Giza. Its base measures roughly 220 meters on each side, a vast square footprint that covers an area comparable to several city blocks. The pyramid contains approximately 1.6 million cubic meters of stone, a mass of material that, combined with the stone in Sneferu's other pyramids, means that Sneferu moved more stone during his reign than any other pharaoh in Egyptian history, including his son Khufu, who built the Great Pyramid. But the numbers, impressive as they are not the point. The point is what the numbers represent: the successful completion of a project that had been the goal of the Egyptian building tradition for more than a century, the achievement that Imhotep's step pyramid had initiated and that Sneferu's earlier failures had brought tantalizingly close. The Red Pyramid is not merely a large stone structure. It is the culmination of a research and development program that spanned generations. A program that had produced failures, crises, collapses, and compromises, and that had finally, at Dahshur, produced the result it had been seeking all along: a true pyramid, built right, standing firm, ready to serve as the model for every pyramid that would follow. By the end of tonight, you're going to understand the story of the pyramid that proved it was possible. The pyramid that translated a century of hard-won knowledge into stone, that vindicated the most expensive building program in the ancient world, and that opened the door to the Great Pyramid of Giza and everything that followed. The story of the Red Pyramid is not a story of genius or inspiration. It is a story of application, of knowledge applied, of lessons learned, of failure transformed into success through the patient, disciplined, unglamorous work of engineers who knew what they were doing because they had already learned what not to do. Before we get started, if you find these mysteries as fascinating as we do, take a second to like the video or subscribe. It is a simple action, but it genuinely helps this channel reach more curious minds like yours. The Red Pyramid's significance extends beyond its role as the first true pyramid. It is the proof of concept, the structure that validated the entire experimental program that Sneferu's building tradition had undertaken, the demonstration that the process of trial, failure, and correction actually produces results. The step pyramid had shown that stone construction was possible. The Meidum pyramid had shown that converting a step pyramid to a true pyramid was dangerous. The bent pyramid had shown that building a true pyramid at a steep angle was beyond the current state of knowledge. The red pyramid showed that building a true pyramid at a conservative angle, with horizontal courses and a properly prepared foundation, was achievable, and the demonstration was so convincing, so complete, and so structurally sound that it gave subsequent builders the confidence to attempt the Great Pyramid at Giza, the largest and most ambitious stone structure in the ancient world. The story of the Red Pyramid is therefore not merely the story of a building, it is the story of a turning point, the moment at which the Egyptian building tradition crossed from experimentation to mastery, from uncertainty to confidence, from the hope that true pyramids were possible to the certainty that they were. The crossing was quiet, it was undramatic, it involved no crises, no collapses, no emergency repairs. It involved only the steady, competent, disciplined application of knowledge that had been gained through decades of experience. The quietness is the point. The undramatic nature of the achievement is its most important feature, because the quietness and the lack of drama are the signs of mastery, the signs that the builders knew what they were doing, that their knowledge was adequate for the task, and that the task could be accomplished without the kind of improvisation and compromise that had characterized the earlier attempts. Now, let's begin. To understand the Red Pyramid, you must first understand what came before it. Not merely the bent pyramid, which has been the subject of a previous episode in this series, but the entire sequence of experiments and failures that preceded the Red Pyramid and that generated the knowledge it embodied. The Red Pyramid did not appear out of nowhere. It was the product of a process, a century-long process of engineering development that began with Imhotep's step pyramid at Saqqara, and that proceeded through a series of increasingly ambitious experiments toward the goal of building a true pyramid with smooth, unbroken sides, rising from base to apex at a consistent angle. The process had three critical predecessors. The first was the step pyramid itself, the revolutionary structure that demonstrated, for the first time in human history, that monumental buildings could be constructed from cut stone. The step pyramid established the basic techniques of stone quarrying, transport, and placement that all subsequent pyramid builders would use, but it did not attempt the true pyramid form. Its stepped profile was a consequence of its construction method. Each step was a separate master bar built on top of the one below, and the overall effect was a staircase rather than a smooth slope. The second predecessor was the Meidum pyramid, Sneferu's first attempt at converting a step pyramid into a true pyramid by filling in the steps with a smooth outer casing. The conversion failed. The casing was not adequately bonded to the underlying stepped core, and the casing eventually collapsed, leaving the stepped core standing alone amid a mountain of rubble. The Meidum failure taught a critical lesson. The lesson that a true pyramid could not be created by simply applying a smooth surface to a stepped structure. The true pyramid form required a different approach to construction, an approach in which the smooth sides were built as an integral part of the structure, rather than added as an afterthought. The third predecessor was the bent pyramid, Sneferu's second attempt at a true pyramid, a structure that began at the ambitious angle of 54 degrees, and that was forced by a structural crisis involving cracking ceilings, settling foundations, and unstable casing courses, to reduce its angle to 43 degrees partway through the construction. The bent pyramid taught multiple lessons. Lessons about the relationship between angle and structural stability, about the importance of foundation preparation, about the dangers of inward-sloping casing courses, and about the need for a more conservative and more carefully engineered approach to the true pyramid form. The political implications of Sneferu's building program deserve attention, because the program was not merely an engineering undertaking. It was a political statement, a demonstration of the pharaoh's power and his capacity to mobilize the resources of the state for monumental construction. The construction of 3 pyramids in a single reign was unprecedented. No previous pharaoh had attempted anything comparable, and the sheer scale of the program communicated a message about the strength and the ambition of the new 4th dynasty that was as powerful as any military campaign or diplomatic achievement. The message was directed at multiple audiences, at the Egyptian population, whose labor and whose taxes funded the construction, at the provincial governors and the court officials, whose loyalty was essential to the functioning of the state, at the priesthood, whose theological endorsement was essential to the legitimacy of the pharaoh's rule, and at the gods themselves, whose approval was the ultimate purpose of the construction. The relationship between Sneferu and his successor, Khufu. The father-son relationship that links the builder of the Red Pyramid to the builder of the Great Pyramid is one of the most important dynastic relationships in Egyptian history, because it represents the transfer of the knowledge and the institutional capability that made the Great Pyramid possible. Khufu did not develop the construction methods for the Great Pyramid from scratch. He inherited them from his father's building program, from the workforce that his father had trained, from the administrative apparatus that his father had developed, and from the specific, concrete, hard-won engineering knowledge that his father's experiments had produced. The inheritance was the most valuable legacy that any pharaoh could leave to his successor, more valuable than gold, more valuable than territory, more valuable than diplomatic alliances. The inheritance was the capacity to build, the knowledge, the organization, and the institutional framework that would allow Khufu to construct the most impressive stone structure in the history of the world. The economic cost of the Red Pyramid was substantial, though less than the cost of the Bent Pyramid, because the Red Pyramid's shallower angle and its more efficient construction methods reduced the volume of stone required and the time needed to complete the structure. The Red Pyramid contains approximately 1.6 million cubic meters of stone, a large volume but significantly less than the roughly 2.6 million cubic meters of the Great Pyramid. The reduction in volume was partly a consequence of the shallower angle. A 43-degree pyramid requires less stone for a given base dimension than a steeper pyramid, and partly a consequence of the more efficient construction methods that the builders had developed through their earlier experiences. The efficiency gains were real. They represented the tangible economic benefits of the learning process that the building program had undergone, the savings that resulted from doing things right rather than doing them wrong and then having to fix them. The training system that produced the skilled workforce for the Red Pyramid was a continuation of the apprenticeship tradition that had been developing throughout Sneferu's building program, a tradition in which young workers learn their skills by working alongside experienced craftsmen, observing their techniques, practicing under their supervision, and gradually acquiring the practical knowledge that could not be transmitted through written instructions alone. The apprenticeship system was the primary mechanism of knowledge transmission in the ancient world, and it was a system that worked, as the quality of the Red Pyramid's construction demonstrates. The workers who built the Red Pyramid were skilled. Their blocks were well cut, their courses were well laid, their joints were tight, and their chambers were structurally sound. The skill was not innate. It was learned through years of practice and observation in the apprenticeship system that the building program had sustained. The religious dimension of the Red Pyramid's construction was as important as the engineering dimension, because the pyramid was not merely a building project, but a sacred undertaking, a project that was motivated by the deepest religious convictions of the Egyptian state, and that was conducted within a framework of ritual practices and theological beliefs that shaped every aspect of the construction. The orientation of the pyramid to the cardinal points, with its entrance on the north face and its primary axis aligned to the celestial north, was a religious decision reflecting the belief that the pharaoh's spirit would travel northward to join the circumpolar stars in the eternal cycle of creation and renewal. The placement of the burial chamber in the interior of the pyramid, protected by millions of tons of stone from the disturbances of the outside world, was a religious decision reflecting the belief that the pharaoh's body must be preserved for eternity in a secure and permanent environment. The entire design of the pyramid was shaped by religious requirements that the builders incorporated into their engineering calculations and that influenced every major design decision, from the angle of the sides to the proportions of the internal chambers. The funerary rituals that were performed at the Red Pyramid complex, the daily offerings, the festival celebrations, the seasonal ceremonies that marked the passage of the agricultural year, were maintained by a permanent priestly staff that was assigned to the pyramid cult, and that was supported by the revenues from estates that had been endowed for that purpose. The cult was intended to operate indefinitely, to maintain the rituals and the offerings for as long as the Egyptian state continued to function, ensuring the perpetual sustenance of the pharaoh's spirit in the afterlife. The endowment of the cult was a significant economic commitment. It diverted resources from other state functions to the permanent support of the funerary establishment, and the cumulative effect of multiple pyramid cults over multiple generations was one of the factors that contributed to the eventual economic strain on the Old Kingdom state. The supply chain that supported the Red Pyramid's construction was essentially the same supply chain that had supported the Bent Pyramid. The same quarries, the same transport routes, the same Nile landing, the same network of suppliers who provided the copper, the timber, the gypsum, and the other materials that the construction required. The continuity of the supply chain was an advantage. It meant that the logistical infrastructure did not need to be built from scratch, but could be adapted from the existing system, with modifications to account for the different location and the different requirements of the new construction. The adaptation was straightforward. The distance from the quarries was similar, the Nile landing was accessible, and the workforce was already in place. The logistical efficiency of the Red Pyramid's construction was therefore significantly higher than it would have been for a project starting from scratch. Another benefit of the continuity that Sneferu's building program provided, the geological survey of the Red Pyramid's foundation site, conducted before the construction began, using methods that the Bent Pyramid's experience had shown to be essential, was one of the most important preparatory activities of the entire project. The survey involved the assessment of the bedrock's load-bearing capacity at multiple points across the site, the identification of weak layers or discontinuities that might cause differential settlement, and the levelling of the surface to the precision that the construction required. The survey was more thorough than the surveys that had preceded the Bent Pyramid's construction, because the builders now understood, from painful experience, that the consequences of inadequate foundation work could be catastrophic, and that the investment of time and effort in foundation preparation was small compared to the cost of the structural problems that inadequate preparation could produce. The quarrying operations that supplied the Red Pyramid with its core blocks were organized as continuous, year-round activities, not seasonal operations limited to the flood period, but permanent industrial processes that operated throughout the agricultural cycle. The quarries were located on the Dahshur plateau, close to the construction site, reducing transport distances and allowing the quarrying and the construction to proceed in synchronized rhythm. The quarrying teams used the standard Old Kingdom techniques: copper chisels, stone hammers, wooden wedges, and the organized labor of experienced quarrymen who had been trained in the specific techniques of limestone extraction. The techniques were proven. They had been refined through decades of practice at multiple sites, and the quarrymen who used them were skilled professionals whose competence was the product of years of apprenticeship and hands-on experience. The transport of the fine Tura limestone casing blocks. The high-quality limestone that was used for the exterior surface of the pyramid required a different logistical operation from the transport of the local core blocks. The Tura quarries were located on the east bank of the Nile, across the river from the construction site at Dahshur. The casing blocks were quarried at Tura, loaded onto boats, transported across the river, and then hauled from the Nile landing to the construction site on sledges. The river crossing added complexity to the transport operation. It required the coordination of the quarrying schedule at Tura with the availability of boats and the water levels of the Nile, and it introduced weather-related delays that could disrupt the supply of casing blocks during periods of unfavorable wind or current, the management of the multiple supply chains, the local quarries for core blocks, the Tura quarries for casing blocks, the Aswan quarries for any granite elements, the Sinai mines for copper, the Lebanese forests for timber, was one of the most demanding aspects of the project administration. Each supply chain had its own timeline, its own transport requirements, its own labor force, and its own set of potential disruptions. The coordination of these multiple chains, ensuring that the right materials arrived at the right time in the right quantities, required an administrative apparatus of considerable sophistication, staffed by scribes and managers who tracked the flow of materials with a precision that the graffiti evidence confirms was characteristic of the Old Kingdom bureaucracy. The alignment of the Red Pyramid to the cardinal points, while less precise than the alignment of the Great Pyramid, was nonetheless a significant achievement that demonstrated the builder's mastery of the astronomical observation techniques that were used to establish true north. The alignment was accomplished by observing the positions of circumpolar stars, stars that rotate around the celestial North Pole without setting below the horizon, and using their positions to establish a north-south line from which the east-west orientation of the pyramid could be derived. The method was simple in principle, but it required careful observation, precise measurement, and the patience to wait for the optimal astronomical conditions before taking the observations that would determine the orientation of the structure. The alignment accuracy at the Red Pyramid, while not as impressive as the Great Pyramid's near-perfect orientation, was sufficient for the religious requirements of the structure, and it represented a significant improvement over the alignments achieved at earlier pyramid sites. The surveying and layout of the Red Pyramid's base, the establishment of the precise square footprint on which the pyramid would be built, required the application of geometric principles that the Egyptian builders had been developing for generations. The base was a square, each side measuring approximately 220 meters, and the squareness was established using rope measurements and the geometric principle that a square can be verified by comparing its diagonals. The precision of the squareness was high. The maximum deviation between the lengths of the four sides was only a few centimeters, a level of accuracy that is comparable to the accuracy achieved at the Great Pyramid, and that demonstrates the refinement of the surveying techniques that the builders had developed. The water leveling technique that was used to establish a flat surface for the pyramid's base, the technique of filling channels cut into the bedrock with water and using the water surface as a reference for leveling, was applied with greater care and greater precision at the Red Pyramid than at the Bent Pyramid. The improvement in leveling precision was a direct response to the Bent Pyramid's experience. The builders understood that a foundation that was not perfectly level would create differential loading that could produce the kind of structural distress they had observed at the earlier site, and they invested the additional time and effort needed to achieve a higher level of precision. The investment was justified. The Red Pyramid's foundation has maintained its level for 4,600 years, without the settlement or the distortion that affected the Bent Pyramid. The limestone quarries that supplied the core blocks for the Red Pyramid were located on the Dahshur plateau itself, close to the construction site and accessible without the need for long-distance transport. The proximity of the quarries was a significant advantage. It reduced the time and the labor required to move each block from the quarry to the pyramid, and it allowed the quarrying and the construction to proceed in parallel without the bottlenecks that would have resulted from a longer transport distance. The quarries were worked using the same techniques that had been developed at the Bent Pyramid site. Copper chisels, stone hammers, wooden wedges, and the organized labor of quarrying teams who had been trained in the specific techniques of limestone extraction during the earlier construction. The scale of Sneferu's total building program, encompassing at least 3 major pyramids, plus their associated funerary complexes, has led some scholars to question how a single reign could have produced so much construction. The answer lies in the extraordinary wealth and organizational capacity of the early 4th dynasty state. a state that controlled the agricultural surplus of the most fertile river valley in the ancient Near East, that commanded a labor force of millions through the corvée system, and that had developed an administrative bureaucracy capable of managing multiple large-scale construction projects simultaneously. The evidence suggests that Sneferu's building projects may have overlapped, that work on the Red Pyramid may have begun before the Bent Pyramid was fully completed, and that the workforce and the supply chains were shared between the two sites, with workers and materials being transferred from the older project to the newer one as the construction priorities shifted. The overlap hypothesis has implications for understanding the relationship between the Bent Pyramid and the Red Pyramid, because if the two projects overlapped, the lessons of the Bent Pyramid's crisis would have been available to the Red Pyramid's designers while the crisis was still unfolding, allowing them to incorporate the lessons into the Red Pyramid's design in real time rather than after the fact. The real-time transfer of knowledge from one project to another, the ability to learn from a failure while it is still happening, and to apply the lessons to a concurrent project before the failure has run its full course, is one of the most efficient forms of organizational learning, and Sneferu's building program may have benefited from exactly this kind of rapid knowledge transfer. The Red Pyramid's position as the culmination of Sneferu's building program raises questions about the pharaoh's personal involvement in the design process. Sneferu reigned for approximately 24 years, long enough to oversee the conception, the construction, and the completion of all three of his major pyramids. The duration of his reign suggests that the building program was not merely a series of disconnected projects, but a sustained, deliberate campaign of architectural development, guided by the pharaoh's personal interest and driven by his personal determination to achieve the goal of a true pyramid. The personal dimension of the building program, the pharaoh's involvement in the design decisions, his reaction to the failures and the successes, his assessment of the lessons and his direction of the next steps, is a dimension that the archaeological evidence can suggest but cannot document directly. The role of the vizier in managing the Red Pyramid's construction, coordinating the quarrying, the transport, the placement, the supply chains, and the workforce, was one of the most demanding administrative positions in the Old Kingdom state. The vizier was responsible not merely for the construction itself, but for the entire support infrastructure that the construction required: the food supply, the tool supply, the medical care, the housing, the record-keeping, and the management of the rotating labor force that supplemented the permanent skilled workers. The administrative competence that the position required was extraordinary, and the fact that the Red Pyramid was completed on schedule, within budget, and without structural failure is the strongest possible evidence that the administrative system functioned effectively, and that the vizier and his staff were equal to the demands of the project. The construction of the Red Pyramid also required the development of specialized tools and equipment that were tailored to the specific demands of true pyramid construction. The copper chisels used for quarrying limestone were manufactured in standardized sizes and shapes, each size designed for a specific task, from the rough cutting of quarry channels to the fine finishing of casing surfaces. The stone hammers, balls of dolerite and other hard stones were selected for their weight, their hardness, and their shape, with heavier hammers used for rough work and lighter hammers used for precision finishing. The wooden sledges were constructed to specific dimensions that balanced load capacity against maneuverability, large enough to carry the heaviest core blocks, but small enough to be maneuvered through the tight spaces of the construction site. The ropes were manufactured in various thicknesses, from thin cordage used for lashing and binding to heavy hawsers used for hauling loaded sledges. Each tool was a product of the accumulated experience of the building tradition, designed and refined through decades of use to meet the specific requirements of pyramid construction. The Red Pyramid incorporated every one of these lessons. Its angle of 43 degrees was the angle that had proven stable in the upper portion of the Bent Pyramid, the angle that the builders had determined, through painful experience, represented the maximum slope that the available materials and methods could safely support. Its casing courses were laid horizontally rather than with the inward slope that had contributed to the instability of the bent pyramid's lower section, a change in technique that eliminated the sloping bedding planes that had acted as potential failure surfaces. Its foundation was more carefully prepared than the foundations of either of its predecessors. The bedrock was leveled with greater precision, the weak layers were identified and addressed, and the overall preparation was more thorough and more systematic than anything that had been attempted before. The Red Pyramid was, in the most literal sense, an applied textbook, a structure in which every major design decision was a direct response to a specific problem that had been identified in a previous construction. The angle responded to the bent pyramid's over-ambitious slope. The course orientation responded to the bent pyramid's unstable casing technique. The foundation preparation responded to the bent pyramid's inadequate foundation. The internal chamber design responded to the cracking and the emergency repairs that had plagued the bent pyramid's lower chamber. Every feature of the Red Pyramid was a lesson translated into stone, and the totality of the lessons, taken together, produced a structure that was stable, sound, and structurally successful in every respect that its predecessors had not been. The site of the Red Pyramid, located approximately 2 kilometers north of the Bent Pyramid on the Dahshur Plateau, was chosen with the same attention to geological and logistical factors that had characterized the choice of the Bent Pyramid site. The bedrock at the Red Pyramid site was assessed for its load-bearing capacity. The builders applied the lessons of the Bent Pyramid's foundation problems by evaluating the quality of the underlying rock more carefully than they had at the earlier site. The proximity to the Bent Pyramid was itself significant. It allowed the builders to draw on the infrastructure, the workforce, and the supply chains that had been established for the earlier project, reducing the logistical startup costs of the new construction and allowing the Red Pyramid project to proceed more efficiently than a new project at a distant site would have done. The construction timeline of the Red Pyramid has been estimated by scholars on the basis of the graffiti that was found on some of the pyramid's blocks, dates and team names written in red ochre by the construction workers during the building process. The graffiti provides one of the most valuable categories of evidence for the pace and the organization of the construction. It records specific dates, specific team names, and specific locations within the pyramid, allowing scholars to reconstruct the progress of the construction with a precision that is not possible for most ancient building projects. The graffiti dates suggest that the Red Pyramid was constructed relatively quickly, perhaps in as few as 17 years, a pace that is comparable to the construction of the Great Pyramid, and that demonstrates the efficiency of the construction methods that the builders had developed through their earlier experiments. The workforce that built the Red Pyramid was organized along the same lines as the workforces that had built the earlier pyramids. Hierarchical teams and divisions, supervised by foremen and administrators, supplied by a logistics system that provided tools, materials, food, and water to the construction site. The workers were skilled professionals, quarrymen, masons, surveyors, and labourers who had been trained in the techniques of stone construction through the apprenticeship system that had developed over the preceding decades. Many of the workers may have been veterans of the Bent Pyramid's construction. Experienced builders who brought to the Red Pyramid project the specific knowledge of what had gone wrong at the earlier site, and of the measures that had been taken to prevent similar problems. The presence of experienced workers who had lived through the Bent Pyramid's crisis, and who carried in their minds and their hands the specific practical knowledge of what the crisis had taught, was one of the most valuable assets of the Red Pyramid project. The knowledge was not theoretical, it was experiential, the kind of knowledge that comes from having seen the cracks in the ceiling, from having inserted the cedar beams into the fractures, from having felt the tremors of the settling foundation, and having watched the walls of the descending passage shift under the weight of the structure above. The workers who carried this knowledge were the living repositories of the lessons that the bent pyramid had taught, and their presence at the Red Pyramid construction site ensured that the lessons would be applied not merely in the abstract design of the structure, but in the concrete, practical, day-to-day execution of the construction itself. The core problem of the Red Pyramid is, paradoxically, the absence of a problem. The structure was built without the kind of dramatic crisis that defined the bent pyramid, without cracking ceilings, without settling foundations, without emergency repairs, and without the radical design modifications that the bent pyramid's crisis had required. The Red Pyramid simply worked. It was designed correctly. It was built competently. It stood, and it continued to stand, without any of the structural distress that had forced the builders to change their plans at the earlier site. The absence of crisis is, from a storytelling perspective, a challenge because crisis is dramatic and the absence of crisis is not. The Bent Pyramid's story is a drama, a narrative of ambition, failure, improvisation, and compromised success that engages the listener because the outcome is uncertain and the stakes are real. The Red Pyramid story lacks this dramatic tension. The outcome is never in doubt, the stakes are lower, and the narrative does not build toward the kind of climactic moment that makes the Bent Pyramid's story so compelling. But the absence of crisis is, from an engineering perspective, the most important feature of the Red Pyramid, because the absence of crisis is the proof that the lessons of the Bent Pyramid were learned. The fact that the Red Pyramid did not crack, did not settle, did not require emergency repairs, and did not need to change its angle partway through the construction is the evidence that the design was correct, that the foundation was adequate, that the course orientation was stable, and that the angle was within the range that the materials and methods could safely support. The absence of crisis is the measure of the knowledge that was gained at terrible cost during the construction of the Bent Pyramid, and that was applied with quiet competence and without fanfare to the construction of the Red Pyramid. The design of the Red Pyramid reflects this knowledge in every detail. The angle of 43 degrees was conservative, deliberately chosen to be well within the range that the Bent Pyramid's experience had shown to be safe, rather than pushing toward the upper limit of what the materials could support. The conservatism was not timidity, it was wisdom, the wisdom of builders who had learned, through painful experience, that the cost of overreaching was far greater than the cost of restraint. The builders of the Red Pyramid did not need to be told to be careful. They had been at the Bent Pyramid. They had seen what happened when the angle was too steep. They had seen the cracks and the settlement and the emergency repairs. They did not need a lecture on the virtues of conservatism. They needed only their own experience, and their experience told them, in the most direct and most persuasive way possible, that 43 degrees was the angle to use. The foundation preparation at the Red Pyramid was more thorough than at any previous pyramid site, reflecting the lesson that the quality of the foundation was as important as the quality of the superstructure in determining the success or failure of the construction. The builders leveled the bedrock surface with a precision that exceeded anything they had achieved before, creating a platform that was flat and stable enough to support the enormous weight of the pyramid without the differential settlement that had caused problems at the Bent Pyramid. The preparation included the removal of weak or fractured rock, the filling of natural depressions in the bedrock surface, and the careful assessment of the rock's load-bearing capacity at multiple points across the site. The thoroughness of the preparation was not excessive. It was proportional to the lessons that the Bent Pyramid had taught about the consequences of inadequate foundation work. The horizontal course orientation of the Red Pyramid, the technique of laying each course of blocks with the bedding planes running level rather than sloping inward, was the most important technical innovation that the Bent Pyramid's crisis had produced, and its consistent application throughout the Red Pyramid was one of the key factors in the structure's success. Horizontal courses eliminated the sloping bedding planes that had acted as potential failure surfaces in the Bent Pyramid's lower section, surfaces along which the casing blocks could slide under the influence of the lateral forces that the pyramid's weight created. The elimination of the failure surfaces made the casing more stable, more resistant to lateral displacement, and more capable of maintaining its position under the long-term stresses that the pyramid's mass would impose. But here's the problem, or rather, here is what makes the Red Pyramid's achievement so significant. The horizontal course technique was not merely a minor adjustment to the existing construction method. It was a fundamental change, a departure from the inward-sloping technique that the builders had inherited from the step pyramid tradition and that they had used for every previous stone construction project. The change required the builders to abandon a technique that was established, familiar, and proven in other contexts, and to adopt a new technique that had been tested only in the upper portion of the bent pyramid under conditions that were different from those that the Red Pyramid would present. The adoption of the new technique required confidence that the bent pyramid's experience was relevant, that the lessons were transferable, and that the new technique would work at the larger scale and under the different conditions of the Red Pyramid's construction. The confidence was justified. The technique worked, and the success of the technique at the Red Pyramid established horizontal coursing as the standard method for all subsequent pyramid construction. The comparison between the Red Pyramid's internal chambers and the Bent Pyramid's internal chambers provides one of the clearest demonstrations of applied learning in the archaeological record. The Bent Pyramid's lower chamber, with its 17-meter cobbled ceiling, its cracked beams, and its emergency cedar repairs, represents the state of knowledge before the crisis. The Red Pyramid's chambers, shorter, wider, more conservatively proportioned and entirely free of structural distress, represent the state of knowledge after the crisis. The difference is the measure of the learning. The corbelled ceilings of the Red Pyramid's 3 chambers are masterpieces of stone engineering, each course projecting slightly beyond the one below, gradually narrowing the space to a single capstone at the top. The proportions are more conservative than the Bent Pyramid's, wider relative to height, which reduces stresses on the upper courses and minimizes the risk of cracking. The change was subtle but significant. The difference between a chamber that cracked and one that stood for millennia. The question of whether the Red Pyramid's builders considered using a steeper angle, whether they debated the possibility of returning to the ambitious 54-degree angle that the Bent Pyramid had attempted, is a question that illuminates the conservative design philosophy that characterized the Red Pyramid's construction. The builders almost certainly considered the steeper angle. It was the angle that had been originally intended for the Bent Pyramid, the angle that would have produced a taller and more imposing structure, and the angle that reflected the full ambition of the Pharaoh's building program. But the builders chose not to use it. They chose the conservative 43-degree angle instead, the angle that the Bent Pyramid's upper section had proven to be stable, the angle that offered the greatest margin of safety, with the least risk of structural problems. The choice of the conservative angle was a decision that prioritized safety over spectacle, a decision that accepted a less impressive visual result in exchange for a more reliable structural performance. The decision was wise, but it was also, in a sense, disappointing. The Red Pyramid is shorter than the Bent Pyramid would have been if the original angle had been maintained. It is less visually striking. It is less architecturally ambitious. The Red Pyramid is, in visual terms, a compromise, a structure that reflects the lessons of failure more than the ambition of aspiration. The compromise is the price of wisdom, the price that the builders paid for the knowledge that the Bent Pyramid had taught them, the price of knowing what they had not known before, and of acting on that knowledge even when the result was less dramatic than what they had originally hoped to achieve. The masonry techniques used in the Red Pyramid's construction demonstrate the high level of craftsmanship that the builders had achieved through years of practice and training. The core blocks were cut to approximate dimensions at the quarry and then trimmed to their final dimensions at the construction site, a 2-stage process that balanced the efficiency of rough cutting at the quarry with the precision of fine finishing at the site. The blocks were placed in courses, horizontal layers that extended across the entire base of the pyramid and that rose course by course from the bottom to the top of the structure. Each course was carefully leveled before the next course was begun, a process that required constant measurement and adjustment to ensure that the cumulative effect of small deviations in individual courses did not produce a visible misalignment in the finished structure. The mortar that was used between the blocks, gypsum plaster, produced by heating gypsum rock and grinding the resulting powder into a fine paste, served multiple functions. It acted as an adhesive, bonding each block to the block below it. It acted as a leveling agent, filling the small gaps between imperfectly fitted blocks and creating a smooth surface on which the next course could be laid. And it acted as a lubricant during the placement process, allowing the blocks to be slid into their final positions with less friction than dry stone-to-stone contact would have permitted. The use of mortar was not unique to the Red Pyramid. It had been used at every previous pyramid site, but the consistency and the quality of the mortar at the Red Pyramid demonstrate the refinement of the technique that the builders had achieved through years of practice. The passage system of the Red Pyramid is simpler and more rational than the bent pyramids. A single entrance, a single descending passage, and a logical sequence of chambers connected by short corridors. The simplicity reflects the clarity of the design, conceived as a unified whole rather than modified during construction. The Red Pyramid's builders knew what they were building from the beginning. The first chamber, a long narrow room with a corbelled ceiling rising roughly 12 meters, is oriented north-south along the pyramid's axis. The second chamber mirrors the first in size and proportions. The third chamber, the burial chamber, is accessed by a passage that rises from the second chamber through the body of the pyramid. The burial chamber's corbelled ceiling rises to roughly 15 meters, shorter than the bent pyramid's 17-meter ceiling, but still impressive, and built with proportions that avoided the structural problems that had plagued its predecessor. The quality of the stonework in the chambers is exceptional. The limestone blocks are cut with precision, the joints are tight, the surfaces are smooth, and the corbelling is regular and consistent throughout. The quality demonstrates the competence of the builders and the effectiveness of the quality control procedures that monitored the construction. The builders measured, they checked, they verified, and the result, chambers that have maintained their structural integrity for 4,600 years, confirms that their measurements, their checks, and their verifications were correct. The structural analysis of the Red Pyramid's corbelled ceilings has revealed the specific engineering principles that the builders applied to achieve the structural soundness that the bent pyramid's ceilings had lacked. The key principle is the relationship between the height of the corbelling and the width of the chamber, a relationship that determines the steepness of the corbelling angle and, consequently, the magnitude of the lateral forces that the corbelling generates. A tall, narrow, corbelled chamber generates larger lateral forces than a short, wide one, because the steeper corbelling angle directs more of the ceiling's weight outward rather than downward, creating the kind of outward thrust that had caused the cracking at the bent pyramid. The Red Pyramid's chambers were designed with a wider base relative to their height, a proportion that reduced the corbelling angle, reduced the lateral forces, and created a more stable configuration that has maintained its structural integrity for more than 4,600 years. The mathematical relationship between chamber proportion and structural stability was almost certainly not understood by the builders in formal mathematical terms. The formal analysis of forces in corbelled structures would not be developed for millennia, but the builders clearly understood the relationship intuitively and practically. Through their observation of the bent pyramid's failure and their recognition that the tall, narrow proportions of the bent pyramid's lower chamber had contributed to the cracking, the intuitive understanding was sufficient. It allowed the builders to select proportions that were structurally sound, even though they could not express the underlying physics in mathematical equations. The relationship between intuitive understanding and formal analysis is one of the most interesting features of the Egyptian building tradition. because it demonstrates that practical engineering competence and can be achieved without theoretical knowledge, that the correct answers to engineering questions can be found through experience and observation without the formal mathematical analysis that modern engineering relies upon. The demonstration is humbling. It reminds us that formal analysis is a tool, not a prerequisite, and that the ancient builders' lack of formal mathematical theory did not prevent them from achieving results that modern engineers find impressive and difficult to replicate. The Red Pyramid's passage system demonstrates the same clarity of design that characterizes its chamber system. The entrance passage, a single descending corridor on the north face, leads directly to the first chamber without the branches, the modifications, or the secondary passages that complicate the bent pyramid's internal layout. The directness of the passage system reflects the confidence of the design. The builders did not need to add secondary passages or additional chambers because the original design was adequate for the ritual and the structural requirements of the pyramid. The design was correct from the beginning, and the correctness of the design is itself the most important evidence for the sufficiency of the builder's knowledge. The Red Pyramid's achievement, the successful completion of a true pyramid without structural crisis, can be fully appreciated only in the context of what had come before. The step pyramid at Saqqara, built roughly a century earlier, had demonstrated that monumental stone construction was possible, but it had not attempted the true pyramid form. The Meidum pyramid had attempted the conversion from step pyramid to true pyramid, and the attempt had resulted in a collapse that demonstrated the dangers of the form. The bent pyramid had attempted a true pyramid from the ground up, and the attempt had resulted in a structural crisis that forced a radical modification of the design. Against this background of partial successes and outright failures, the Red Pyramid's quiet, undramatic success was an achievement of the first order, a demonstration that the true pyramid form was not merely theoretically possible but practically achievable, that the engineering challenges could be overcome, and that the builders possessed the knowledge and the skill to construct a smooth-sided pyramid of monumental scale that would stand for millennia. The achievement was all the more remarkable because it was accomplished without any dramatic breakthrough or revolutionary innovation. The Red Pyramid did not introduce any fundamentally new technology. It did not employ any construction method that had not been used before. It did not rely on any material that was not already available. The Red Pyramid's achievement was not one of invention, but of application. The careful, disciplined, systematic application of existing knowledge to a familiar problem, producing a result that was correct, not because the knowledge was new, but because the knowledge was finally sufficient. The sufficiency of the knowledge, the adequacy of the existing methods and the existing understanding for the task at hand, was the Red Pyramid's most important discovery. The discovery was not dramatic, it was not exciting. It did not produce the kind of eureka moment that popular accounts of scientific and engineering progress tend to celebrate. But it was the most important discovery of the entire building program, because it established that the goal was achievable, and that the path to the goal ran through the disciplined application of proven methods rather than through the invention of new ones. The Red Pyramid also demonstrated something about the nature of engineering confidence, about the relationship between confidence and competence, between the belief that a task can be accomplished and the actual ability to accomplish it. The builders of the Red Pyramid were confident. They began the construction with the expectation that the design would work, that the methods would be adequate, and that the structure would stand. The confidence was justified. The pyramid did work, the methods were adequate, and the structure did stand. But the confidence was not blind. It was based on experience, on the specific, concrete, hard-won knowledge that the bent pyramid's crisis had provided. The confidence was earned through the painful process of failure and correction that had characterized the preceding decades of the building program. And the earning of the confidence, the transformation of uncertainty into justified belief through the process of learning from failure, was itself one of the most important achievements of the building tradition. The Red Pyramid also provides evidence for the quality control procedures that the builders used to ensure that the construction met the standards of precision and craftsmanship that the project required. The rigorous quality control was deeply embedded in the construction process. It was not a separate activity conducted after the work was complete, but an ongoing process of measurement, inspection, and correction that accompanied every stage of the construction. The surveyors checked the alignment of each course against the reference lines that defined the pyramid's geometry. The foreman inspected the quality of each block, checking for cracks, for irregularities in size or shape, and for defects in the stone that might compromise the structural integrity of the finished structure. The scribes recorded the progress of the work, tracking the number of courses laid, the volume of stone moved, and the consumption of tools and materials, creating a detailed running account of the construction that allowed the administrators to monitor the pace of the work and to identify and address any deviations from the schedule. The quality control procedures were not merely bureaucratic formalities. They were essential elements of the construction process that contributed directly to the structural soundness and the geometric precision of the finished pyramid. The procedures ensured that errors were detected and corrected before they could accumulate, before a small misalignment in one course could grow, through successive courses, into a visible deviation in the finished surface. The procedures ensured that defective blocks were identified and rejected before they were placed in the structure, preventing the incorporation of weak or flawed material that might compromise the structural performance of the pyramid. And the procedures ensured that the pace of the construction was maintained at a level that was consistent with the quality standards, preventing the kind of rushed work that sacrifices quality, speed, and that can produce structural problems that are not apparent until years or decades after the construction is complete. The organizational discipline that the quality control procedures required was itself one of the most impressive aspects of the Red Pyramid's construction. Because the discipline needed to maintain consistent quality standards across a construction project of this scale and duration is one of the most demanding challenges in any engineering endeavor. The temptation to cut corners, to accept lower standards, to prioritize speed over quality is constant in any large construction project. And the resistance to this temptation requires institutional structures that enforce the standards, regardless of the pressures of the schedule and the demands of the budget. The Red Pyramid's builders maintained the standards, and the 4,600-year survival of the structure is the proof that the discipline was real and that the quality it produced was genuine. The temperature and humidity conditions inside the Red Pyramid's chambers have been studied by conservation specialists who are concerned about the long-term preservation of the limestone surfaces. The chambers maintain a relatively stable internal environment. The massive stone walls and ceiling act as thermal insulators, moderating the temperature fluctuations that affect the exterior surface and creating conditions that are more stable than those found in open-air structures. The stability of the internal environment has contributed to the preservation of the chambers. The limestone surfaces are in generally good condition, with relatively little of the flaking and deterioration that affects the exterior blocks. The stability is itself a product of the design. The massive construction of the pyramid creates an insulating envelope that protects the interior from the extreme temperature variations of the desert climate, a consequence that the builders may not have intended, but that has contributed to the long-term preservation of the spaces they created. The remarkable acoustics of the Red Pyramid's interior chambers are a distinctive feature that modern visitors notice immediately. The corbelled ceilings create resonant spaces that amplify and sustain sound in ways that are striking and that may have had ritual significance for the ancient Egyptians. The resonance of the chambers, the way that a spoken word or a chanted prayer is sustained and amplified by the reflective limestone surfaces, would have enhanced the impact of the funerary rituals that were performed in the chambers, giving the priests' voices a power and a presence that the open air could not provide. The acoustic properties of the chambers may have been intentional, designed by builders who understood, through experience with previous tomb chambers, that the specific proportions and the reflective materials of the space affected the quality of the sound within it. The entrance passage descends at approximately 27 degrees, a gentle slope carefully constructed with precisely cut limestone blocks, maintaining alignment and integrity across millennia. The passage is narrow, roughly 1 meter wide and 1.2 meters high, requiring visitors to stoop as they descend into the pyramid's interior. The narrowness was deliberate, a security measure designed to make unauthorized entry difficult and to limit the size of the objects that could be removed from the chambers by potential tomb robbers. The internal structure of the Red Pyramid provides additional evidence for the application of the Bent Pyramid's lessons. Evidence that the builders had learned not only about the external structure of the pyramid, but about the internal chambers and passages as well. The Red Pyramid contains 3 internal chambers, all accessed through a single entrance on the north face, all located relatively low in the pyramid and all built with corbelled ceilings that are shorter and more conservatively proportioned than the corbelled ceiling of the Bent Pyramid's lower chamber. The first chamber is located at approximately ground level, a long, narrow room with a corbelled ceiling that rises to a height of roughly 12 meters. The second chamber is similar in size and proportions to the first, a parallel room located at the same level, accessed by a short passage from the first chamber. The third chamber, the burial chamber, where the remains of the pharaoh were deposited, is located at a higher level, accessed by a passage that rises from the second chamber through the body of the pyramid. The burial chamber has a corbelled ceiling that rises to a height of roughly 15 meters, shorter than the 17-meter ceiling of the Bent Pyramid's lower chamber and built with proportions that were more conservative and more structurally sound. The conservative proportions of the Red Pyramid's chambers reflect the lesson that the Bent Pyramid's lower chamber had taught. The lesson that tall, narrow corbelled chambers were vulnerable to cracking under heavy loads. The Red Pyramid's chambers are wider relative to their height than the Bent Pyramid's lower chamber, a change in proportion that reduced the stresses on the ceiling beams and that improved the overall structural performance of the chamber system. The change was not dramatic, it was a matter of degrees, of subtle adjustments to the proportions and the dimensions that would not be visible to the casual observer, but that were significant in terms of the forces and the stresses that the structure would experience over its lifetime. The absence of structural distress in the Red Pyramid's internal chambers is the single most important piece of evidence for the success of the design line, because the internal chambers were the elements that had failed most dramatically at the Bent Pyramid, and their soundness at the Red Pyramid demonstrates the specific problems that had caused the Bent Pyramid's crisis had been correctly identified and successfully addressed. The absence of cracks in the ceiling beams, the absence of settlement in the walls and passages, the absence of any need for emergency repairs. These absences are not merely the lack of negative evidence. They are positive evidence. Evidence that the design was correct, that the foundation was adequate, that the proportions were sound, and that the builder's understanding of the forces and the materials was now sufficient for the task. The question of how the builders verified the structural soundness of the chambers during the construction, how they monitored the condition of the ceiling beams, checked for signs of cracking or settlement, and confirmed that the structure was performing as intended, is a question that the evidence does not directly answer, but that the Bent Pyramid's experience makes it possible to address indirectly. The builders of the Bent Pyramid had monitored their structure. They had detected the cracks in the lower chamber ceiling. They'd observed the settlement in the descending passage walls, and they had responded to these observations with the emergency repairs and the design modifications that saved the pyramid from catastrophic failure. The same monitoring practices were almost certainly applied at the Red Pyramid. The builders would have inspected the chambers regularly, checked for signs of distress, and maintained a state of vigilance that their experience at the bent pyramid had shown to be necessary. The vigilance was rewarded by the absence of problems, by the reassuring confirmation, inspection after inspection, that the chambers were sound, that the ceilings were intact, that the walls were stable, and that the structure was performing exactly as the design intended. The relief that the builders must have felt. The relief of seeing a structure succeed where its predecessor had failed. The relief of knowing that the lessons had been learned and that the knowledge was sufficient, is one of the human dimensions of the Red Pyramid's story that the archaeological evidence can suggest, but cannot document directly. The emotions of the builders are as lost as the emotions of the pharaoh, buried beneath 4,600 years of silence. But the emotions were real, and the relief of success, after the anxiety of the bent pyramid's crisis, must have been profound. The placement of the chambers within the body of the pyramid, all three chambers located relatively low, near the base of the structure, reflects a conservative design philosophy that prioritized structural safety over architectural ambition. The bent pyramid's lower chamber had been located deeper within the pyramid, closer to the center of the structure, where the overlying weight was greater and where the compressive and lateral forces were more intense. The Red Pyramid's chambers were located closer to the base, where the overlying weight was less and where the forces were more manageable. The placement was a deliberate design decision, a recognition that the structural performance of the chambers depended not only on their proportions but on their position within the pyramid, and that a conservative position close to the base provided a greater margin of safety than a more central position that would have exposed the chambers to greater forces. The burial chamber, the third and highest of the three chambers, is the space that was designed to receive the pharaoh's body and the funerary equipment that would sustain his spirit in the afterlife. The chamber is relatively small, smaller than the king's chamber of the Great Pyramid, but it is well proportioned and well constructed, with a corbelled ceiling that rises to approximately 15 meters and walls of carefully cut and closely fitted limestone blocks. The floor of the chamber is at a level that is above the base of the pyramid. The chamber is accessed by a short passage that rises from the second chamber, requiring the visitor to climb upward through the body of the pyramid to reach the burial space. The upward approach to the burial chamber may have had symbolic significance. The ascent from the lower chambers to the burial chamber may have represented the pharaoh's ascent from the earthly realm to the celestial realm, a physical reenactment of the spiritual journey that the pyramid was designed to facilitate. And it gets worse. For anyone who underestimates the significance of the Red Pyramid's achievement, because the chambers of the Red Pyramid show none of the signs of structural distress that characterize the bent pyramid's lower chamber. There are no cracks in the ceiling beams. There are no emergency timber repairs. There are no signs of settlement or deformation in the walls or the passages. The chambers are structurally sound, as sound today, after 4,600 years, as they were on the day they were completed. The soundness is the proof that the lessons were learned, that the design was correct, and that the builders' knowledge was now sufficient for the task they had set themselves. The Red Pyramid story illuminates a broader pattern in the history of technology and engineering. The pattern in which the most important advances are not the first attempts but the first successes, not the experiments that generate the knowledge, but the applications that demonstrate that the knowledge is sufficient. The first attempt gets the attention, the first success gets the results, and the Red Pyramid was the first success, the first structure that demonstrated, beyond any reasonable doubt, that the Egyptian builders possessed the knowledge, the skill, and the organizational capacity to construct a true pyramid of monumental scale without structural failure. The first exploration examines the construction graffiti, the dates, team names, and orientation marks that were written in red ochre on the blocks of the Red Pyramid during the construction process, and that provides some of the most detailed evidence available for the pace and the organization of pyramid construction in the Old Kingdom. The graffiti was discovered on blocks throughout the pyramid, on blocks in the core, on blocks in the passages, and on blocks in the chambers. The inscriptions include dates, expressed in terms of the regnal years of Sneferu, the number of the month, and the day within the month, that allows scholars to determine when specific blocks were placed, and therefore to reconstruct the pace of the construction. The inscriptions also include team names, the names of the work gangs that quarried, transported, and placed specific blocks, written on the blocks as identification marks, that allowed the administrators to track the progress of each team and to ensure that the work was proceeding according to schedule. The team names are revealing. They include names like the South Gang and the Green Gang that identify the teams by their position or their assignment within the construction organization. The names are consistent with the team names that have been found at other pyramid sites, including the Great Pyramid, where similar graffiti in the stress-relieving chambers above the King's Chamber identifies teams with names like Friends of Khufu. The consistency of the naming convention across multiple pyramid sites suggests that the workforce organization was standardized, that the same organizational structures and the same naming practices were used from one construction project to the next, providing continuity and institutional memory that facilitated the transfer of knowledge and experience between projects. The dates in the graffiti have been used by scholars to estimate the construction timeline of the Red Pyramid, and the estimates suggest that the construction was completed in a remarkably short period, perhaps as few as 17 years. The speed of the construction is significant. It demonstrates that the builders had achieved a level of efficiency in their quarrying, transport, and placement operations that allowed them to move and place stone at a rate that was comparable to, or even faster than, the rate achieved during the construction of the Great Pyramid a generation later. The efficiency was the product of the experience and the organizational improvements that the earlier projects had generated. The same workers, the same methods, the same supply chains, refined and optimized through years of practice, operating at a level of productivity that reflected the accumulated learning of the entire building program. The second exploration examines the Red Pyramid's casing, the smooth outer surface that was designed to give the pyramid its finished appearance, and that has been almost entirely removed over the centuries by stone robbers. The Red Pyramid originally had a casing of fine white limestone, quarried from the Tura quarries on the east bank of the Nile and transported across the river to the construction site. The Tura limestone was the premium building material of the Old Kingdom, harder, denser, and more uniform in color than the local Giza Formation limestone that constituted the core of the pyramid. The casing was designed to create a smooth, continuous surface, a gleaming white face that would reflect the Egyptian sun and that would proclaim to every person who saw it from the Nile Valley below the power and the permanence of the pharaoh whose tomb it was. The casing has been almost entirely removed, stripped by stone robbers who carried the high-quality Tura limestone away for use in later construction projects. A few casing stones remain at the base of the pyramid, their smooth, angled surfaces providing a glimpse of the pyramid's original appearance, and confirming that the casing technique was the horizontal course method that the bent pyramid's experience had validated. The removal of the casing has exposed the core blocks, the locally quarried limestone blocks that constitute the bulk of the pyramid's mass and whose reddish iron oxide content gives the pyramid the color for which it is named. The third exploration examines the question of whether the Red Pyramid was actually used as Sneferu's burial place, a question that has been debated by scholars and that remains unresolved. Human remains were discovered in the Red Pyramid's burial chamber, fragmentary bones that were found scattered on the floor of the chamber and that may represent the remains of the pharaoh himself. The bones have been studied by physical anthropologists, but the results have been inconclusive, partly because the remains are fragmentary and partly because the bones may have been disturbed by ancient tomb robbers who entered the chamber in antiquity and scattered the contents in their search for valuable grave goods. The identification of the bones as Sneferu's remains is therefore uncertain. The bones may belong to the pharaoh, or they may belong to a later burial that was placed in the chamber after the original contents had been removed. The question of Sneferu's burial is complicated by the fact that Sneferu built multiple pyramids, and the question of which pyramid actually served as his final resting place has never been definitively resolved. Some scholars argue that Sneferu was buried in the Red Pyramid, the last and most successful of his constructions, the pyramid that was specifically designed to be a true pyramid, and that was completed during his lifetime. Others argue that Sneferu was buried in the Bent Pyramid, pointing to the Bent Pyramid's more elaborate internal structure, its two-chamber systems, and its closer association with the satellite pyramid and the Valley Temple that were essential components of the funerary complex. The debate reflects the unusual character of Sneferu's building program, a program that produced multiple pyramids rather than a single one, and that left scholars with the unprecedented problem of determining which of several structures was the pharaoh's actual tomb. The fourth exploration examines the Red Pyramid's position in the sequence of Egyptian pyramid construction. Its role as the bridge between the experimental period of the early 4th dynasty and the mature period that produced the pyramids of Giza. The Red Pyramid is the pivotal structure in this sequence, the structure that marks the transition from experimentation to mastery, from the bold but risky improvisations of the Bent Pyramid to the confident, systematic, precision-engineered construction of the Great Pyramid. The transition was not merely a matter of getting the design right. It was a matter of establishing a standard, a set of proven methods and proven proportions that could be replicated with confidence at subsequent construction sites. The Red Pyramid established this standard, its 43-degree angle, its horizontal courses, its carefully prepared foundation, and its conservatively proportioned internal chambers became the template that subsequent builders would follow, modify, and eventually perfect in the construction of the pyramids at Giza. The graffiti found on the blocks of the Red Pyramid constitutes one of the most valuable categories of evidence for the organization and the pace of Old Kingdom pyramid construction. Evidence that is all the more valuable because it comes from the actual construction process rather than from later descriptions or interpretations. The graffiti was written in red ochre, a pigment that was readily available at the construction site, and that was used by the workers and the administrators for a variety of purposes, including marking blocks for identification, recording dates and team assignments, and noting the orientation of blocks to ensure that they were placed in the correct position. The red ochre marks were not intended to be permanent. They were working marks, functional inscriptions that served the needs of the construction process, and that were not designed to be seen after the construction was complete. But the marks have survived, preserved on the interior surfaces of the blocks where they were protected from the weathering and the erosion that would have destroyed them on the exterior surfaces. The dates in the graffiti are expressed in terms of the regnal years of Sneferu, the pharaoh in whose name the pyramid was being built. The dates include the year, the month, and the day, providing a level of chronological precision that is rarely available for ancient construction projects, and that allows scholars to determine not merely the overall construction timeline, but the pace of construction at specific points during the building process. The analysis of the dates has revealed that the construction proceeded at a remarkably consistent pace. The number of courses laid per year remained relatively stable throughout the construction period, suggesting that the workforce was operating at a steady, sustainable rate rather than at a pace that fluctuated dramatically from one period to the next. The consistency of the construction pace is itself significant because it demonstrates the effectiveness of the organizational system that managed the project. A construction project that proceeds at a consistent pace is a project that is well managed, a project in which the supply of materials matches the pace of construction, in which the workforce is adequately staffed and adequately supplied, and in which the administrative apparatus is functioning efficiently enough to maintain the momentum of the work without interruptions or bottlenecks. The consistent pace of the Red Pyramid's construction is evidence of organizational maturity, the maturity of a construction system that had been developed and refined over the preceding decades, and that was now operating at a level of efficiency that reflected the accumulated experience and the institutional knowledge of the entire building program. The team names in the graffiti provide insight into the social organization of the workforce. The names identify specific teams, groups of workers who were assigned to specific tasks and who identified themselves with specific designations. The team names include geographic references, names that identify the teams by their place of origin or their assigned position within the construction site, and symbolic references that suggest a sense of group identity and group pride among the workers. The team names are consistent with the names found at other pyramid sites, including the Great Pyramid, where similar graffiti has been found in the stress-relieving chambers above the King's Chamber, suggesting that the workforce organization was standardized as across the building program, and that the same organizational structures and naming conventions were used from one project to the next. The question of how many workers were employed at the Red Pyramid at any given time is one that the graffiti helps to address, but does not definitively answer. The graffiti identifies specific teams and specific dates, but it does not provide a comprehensive census of the workforce. The estimates of workforce size are based on calculations that combine the volume of stone moved, the estimated rate of quarrying and transport, the assumed construction timeline, and the known organizational structure of the teams, calculations that produce estimates ranging from several thousand to perhaps 20,000 workers at peak periods. The estimates are uncertain. They depend on assumptions about variables that cannot be measured directly, but they are consistent with the estimates for other pyramid construction projects and with the evidence from the workers' settlements that have been excavated at Giza. The fifth exploration concerns the Red Pyramid's funerary complex, the ensemble of structures that surrounded the pyramid and that served the ritual functions of the pharaoh's funerary cult. The funerary complex of the Red Pyramid is less well preserved than the complexes of some later pyramids. Its mortuary temple, its causeway, and its valley temple have been damaged by centuries of stone robbing and erosion. But the surviving remains provide evidence for the basic layout and the basic functions of the complex, a layout that was consistent with the emerging standard for pyramid complexes, and that would be elaborated and refined at subsequent sites as the mortuary temple, located on the eastern face of the pyramid, was the ritual center of the complex, the place where the daily offerings and prayers that sustained the pharaoh's spirit in the afterlife were performed. The causeway, connecting the mortuary temple to the valley temple near the Nile, was the ceremonial pathway along which the funeral procession moved from the world of the living to the world of the dead. The valley temple, located at the edge of the cultivation, was the point of contact between the complex and the living world, the place where the funeral rituals began and where the provisions for the cult were received. The Red Pyramid's role in establishing the standard funerary complex layout. The arrangement of mortuary temple, causeway, valley temple, and subsidiary structures around the central pyramid is an aspect of its significance that extends beyond the pyramid itself to the entire tradition of Egyptian funerary architecture. The layout that was developed at the Red Pyramid would be refined and elaborated at Giza, where the pyramid complexes of Khufu, Khafre, and Menkaure would take the basic elements established at Dahshur and develop them into the most impressive funerary ensembles in the ancient world. The mortuary temple of the Red Pyramid, located on the eastern face of the pyramid, has been partially excavated and provides evidence for the ritual functions that the temple was designed to serve. The temple contained an offering hall, a space where the daily offerings of food, drink, and incense were presented to the spirit of the deceased pharaoh, and a series of subsidiary rooms that served specific ritual purposes. The temple was relatively simple, less elaborate than the mortuary temples that would be built at Giza in the following generation, but it established the basic architectural program that subsequent mortuary temples would follow. The causeway that connected the mortuary temple to the valley temple has been traced across the plateau, its path running roughly east-west from the pyramid to the edge of the cultivation. The causeway was a covered corridor, enclosed by walls on both sides, and roofed to protect the procession from the sun and from observation by unauthorized persons. The causeway was the ritual pathway, the route along which the funeral procession moved from the world of the living to the world of the dead. A journey that was both physical and symbolic, marking the transition from the temporal to the eternal. The question of the Red Pyramid's place in Sneferu's personal religious program. The question of what the pyramid meant to the pharaoh who built it and how it related to his other pyramids is one that connects the engineering story to the personal story of a man who spent his entire reign building tombs for himself. Sneferu's building program was not merely an engineering project. It was a personal quest, a quest for the perfect tomb, the structure that would ensure his eternal survival and that would serve as the instrument of his transformation from mortal king to immortal God. The quest produced 3 pyramids, each one a response to the failures and the limitations of the previous one, each one bringing the pharaoh closer to the perfection he sought. The Red Pyramid was the fulfillment of the quest, the structure that achieved what the earlier attempts had not, the pyramid that was smooth, complete, and structurally sound. The comparison between the Red Pyramid and the Great Pyramid, the comparison between the first successful true pyramid and the most famous true pyramid, provides one of the most instructive analytical frameworks in the history of architecture. The 2 pyramids share a common ancestry. They are both products of the Sneferu Khufu building tradition, both built by workforces that were trained in the same techniques, both designed according to the same basic principles of stone construction. But they differ in scale, in precision, and in the ambition of their internal structures, difference that reflect the development of the tradition over the generation that separated them. The scale difference is the most obvious. The Great Pyramid's base measures approximately 230 meters on each side, compared to the Red Pyramid's approximately 220 meters. The Great Pyramid stands approximately 146 meters tall, compared to the Red Pyramid's approximately 104 meters. The difference in height is largely due to the difference in angle. The Great Pyramid's steeper angle of approximately 51 degrees produces a taller structure for a given base dimension than the Red Pyramid's shallower angle of approximately 43 degrees. The steeper angle at Giza represents the extension of the proven methods beyond the conservative limits that Sneferu's builders had established. An extension that was made possible by the confidence that the Red Pyramid's success had generated. The precision difference is more subtle but equally significant. The Great Pyramid's base is level to within 2.1 centimeters across its entire area, compared to a larger deviation at the Red Pyramid. The Great Pyramid's alignment to true north deviates by less than 3/60ths of a degree, compared to a larger deviation at the Red Pyramid. The improvements in precision reflect the refinement of the surveying and leveling techniques over the intervening generation. The same techniques, applied with greater care and greater skill, producing results that were incrementally better than those achieved at the earlier site. The internal structure difference is the most dramatic. The Great Pyramid's internal chambers. The King's Chamber, with its flat granite ceiling and its 5 stress-relieving chambers. The Queen's Chamber, with its gabled roof. The Grand Gallery, with its magnificent corbelled corridor, are far more elaborate and far more technically ambitious than the Red Pyramid's 3 simple corbelled chambers. The elaboration reflects the growing confidence of the builders, the willingness to attempt more complex internal structures, now that the basic structural soundness of the true pyramid form had been demonstrated. The stress-relieving chambers above the King's Chamber represent a particularly sophisticated innovation, a system for distributing the enormous weight above the burial chamber that goes far beyond anything attempted at the Red Pyramid, and that demonstrates a level of structural understanding that was the product of the continued development of the building tradition after the Red Pyramid's completion. The comparison reveals the Red Pyramid as the essential stepping stone, the structure that provided the proven foundation on which the Great Pyramid's innovations were built. The Great Pyramid's innovations were real and impressive. The steeper angle, the larger scale, the more elaborate internal structure. But the innovations were possible only because the basic parameters of true pyramid construction had already been established at the Red Pyramid. The innovations were extensions, not departures. They built on the Red Pyramid's foundation. They did not replace it. And the foundation, the proven methods, the validated design parameters, the demonstrated structural soundness, was the Red Pyramid's most important contribution to the building tradition. The Red Pyramid's contribution to the development of Egyptian funerary architecture extended beyond the pyramid itself to encompass the entire funerary complex. The ensemble of structures that surrounded the pyramid and that served the ritual functions that the Egyptian religious system required. The mortuary temple, the ritual center of the complex, located on the eastern face of the pyramid, was designed to house the daily offerings and ceremonies that sustained the pharaoh's spirit in the afterlife. The temple's layout, with its offering hall, its subsidiary chambers, and its courtyard, established a pattern that would be elaborated at Giza and at subsequent pyramid sites, where the mortuary temples became increasingly large and increasingly complex. The causeway, the covered, walled corridor that connected the mortuary temple to the valley temple, was the ceremonial pathway along which the funeral procession moved from the world of the living to the world of the dead. The causeway was more than a practical connection between two buildings. It was a ritual space, a transitional zone between the fertile floodplain of the Nile Valley and the arid desert of the Pyramid Plateau, between the green world of agricultural life and the sandy world of eternal rest. The journey along the causeway was a symbolic journey, a physical enactment of the transition from life to death that the funeral ceremony was designed to facilitate and to solemnize. The Valley Temple, located at the edge of the cultivation, where the floodplain met the desert, was the point of contact between the funerary complex and the living world. The Valley Temple received the funeral procession, hosted the preliminary rituals of purification and preparation, and served as the entry point to the causeway that led to the pyramid above. The Valley Temple of the Red Pyramid has been partially excavated, and the surviving remains provide evidence for the basic layout and the decorative program that would be developed more fully at the Giza pyramid complexes in the following generation. The ensemble of structures that constituted the Red Pyramid's funerary complex, the pyramid, the mortuary temple, the causeway, the Valley Temple, established a standard layout that would be followed, with variations and elaborations, at every major pyramid site for the next several centuries. The standardization was not rigid. Each subsequent complex adapted the basic layout to the specific conditions of its site and to the specific religious requirements of its patron. But the fundamental elements, the central pyramid, the eastern mortuary temple, the connecting causeway, the Valley Temple at the cultivation edge, remained constant, providing a framework of continuity within which individual variations could be accommodated. The Red Pyramid was the first complex to establish this standard layout in its fully developed form, and the establishment of the standard was one of the most important contributions of Sneferu's building program to the Egyptian architectural tradition. The workers' settlement associated with the Red Pyramid has not been identified and excavated with the same thoroughness as the workers' settlement at Giza, primarily because the Dahshur Plateau has received less archaeological attention than the Giza Plateau, and because the settlement remains may be buried beneath later construction or located in an area that has not yet been systematically surveyed. The identification and excavation of the Red Pyramid's workers' settlement would be a significant archaeological discovery. It would provide direct evidence for the organization, the provisioning, and the daily life of the workforce that built the first true pyramid, evidence that will complement the graffiti data and provide a more complete picture of the human dimensions of the construction process. The relationship between the Red Pyramid and the nearby tombs of the 4th Dynasty officials who served Sneferu provides additional context for understanding the social world in which the pyramid was built. The officials who managed the construction, who administered the funerary cult, and who served the pharaoh in various administrative and religious capacities were buried in tombs that were clustered near the pyramid complex, their tombs oriented toward the pyramid and their funerary provisions dependent on the same institutional structures that sustained the pharaoh's cult. The deliberate clustering of the officials' tombs near the pyramid clearly reflects the hierarchical nature of the Old Kingdom social system, a system in which proximity to the pharaoh, even in death, was a marker of status and a source of spiritual benefit. The inscriptions in the officials' tombs provide additional information about the administrative structures that managed the pyramid complex. The titles and the responsibilities of the officials, the detailed organizational hierarchy of the funerary cult, and the specific economic arrangements and endowments that funded the cult's ongoing operations. The information is fragmentary. Many of the tombs have been damaged or destroyed, but the surviving inscriptions nevertheless provide valuable and illuminating evidence for the broader institutional framework within which the Red Pyramid complex functioned and for the social relationships that connected the pyramid to the broader world of Fourth Dynasty society. The question of the Red Pyramid's original appearance, how the pyramid looked when its construction was complete, before the casing was stripped, and the funerary complex was damaged by centuries of stone robbing and erosion, is a question that can be answered only approximately through the combination of archaeological evidence and informed reconstruction. The pyramid was originally covered in a casing of fine white Tura limestone, the same high-quality limestone that was used for the casing of the Great Pyramid and that gave the finished pyramids their characteristic gleaming white appearance. The casing transformed the rough reddish core blocks into a smooth, continuous surface that reflected the sunlight and that was visible from a great distance, a beacon in the desert that proclaimed the power and the permanence of the pharaoh whose tomb it was. The capstone, the pyramidion that crowned the apex of the structure, may have been made of a different material than the casing, possibly granite or a hard stone covered with gold leaf or electrum, designed to catch the first rays of the rising sun and to proclaim the connection between the pyramid and the solar theology that underlay the funerary beliefs of the Old Kingdom. No capstone has been found at the Red Pyramid. It may have been removed in antiquity, or it may have fallen and been broken, its fragments scattered and lost over the centuries. The absence of the capstone is one of the many losses that the Red Pyramid has suffered over its long history. Losses that have diminished its visual impact, but that have not diminished its structural integrity or its historical significance. The broader context of Fourth Dynasty civilization provides the backdrop against which the Red Pyramid's achievement must be understood. The Fourth Dynasty was the peak of Old Kingdom power, the period when the Egyptian state commanded the greatest resources, wielded the greatest authority, and produced the most impressive monuments in the history of pharaonic civilization. The dynasty was founded by Sneferu, whose building program established the technical and organizational foundations of the tradition, and was continued by Khufu, Khafre, and Menkaure, whose pyramids at Giza represented the tradition's fullest and most impressive expression. The wealth of the Fourth Dynasty was agricultural, derived from the annual flooding of the Nile, which deposited a layer of rich silt on the floodplain and created the conditions for the intensive farming that sustained the population and generated the surplus wealth that funded the state's activities. The surplus was enormous. Egypt was the most productive agricultural region in the ancient Near East, and the state's share of the surplus was large enough to support not only the administrative and military establishments, but also the massive construction programs that the pharaohs undertook. The economic foundation of the pyramid building program was the agricultural productivity of the Nile Valley, and the scale of the program reflected the scale of the productivity. The administrative apparatus of the Fourth Dynasty state was one of the most sophisticated bureaucracies in the ancient world. A centralized system of taxation, labor management, and resource allocation that gave the pharaoh and his officials control over the economic output of the entire country. The apparatus had been developing since the earliest dynasties, but it reached its peak of efficiency and its peak of ambition during the Fourth Dynasty, when it was called upon to manage construction projects of unprecedented scale and complexity. The Red Pyramid was one of the products of this administrative apparatus, an enormous structure that simply could not have been built without the capacity to recruit, organize, and sustain a workforce of thousands, to manage supply chains stretching the length of Egypt, and to coordinate the many parallel activities that the construction required. The military dimension of the Fourth Dynasty state also contributed to the pyramid building program, though the contribution was indirect rather than direct. The military secured Egypt's borders, maintained control over the desert routes that connected the Nile Valley to the copper mines of Sinai and the quarries of the Eastern Desert, and protected the trade routes that brought timber from Lebanon and other materials from foreign sources. The military also provided logistical expertise that was transferable to construction projects. The skills of organizing and moving large numbers of people, of maintaining supply lines over long distances, and of managing complex operations under difficult conditions were skills that the military had developed through its own activities, and that were applicable to the challenges of pyramid construction. The religious institutions of the Fourth Dynasty, the priesthood of Re at Heliopolis, the priesthood of Ptah at Memphis, and the various local priesthoods that served the temples of the gods throughout Egypt, provided the theological framework within which the pyramid building program was conceived and justified. The priesthood articulated the religious beliefs that motivated the construction: the belief in the pharaoh's divinity, the belief in the afterlife, the belief that the pharaoh's survival in the afterlife was essential to the continued prosperity of the state. The priesthood also participated in the design process, advising the architects on the religious requirements that the pyramid and its complex needed to satisfy, including the orientation, the placement of chambers, and the ritual spaces that the funerary cult required. The convergence of economic wealth, administrative sophistication, military capability, and religious motivation that characterized the Fourth Dynasty was the essential precondition for the pyramid building program, and the Red Pyramid was the first structure to fully exploit this convergence, producing a true pyramid that demonstrated the capacity of the Fourth Dynasty state to accomplish what no previous state had accomplished. The role of the Red Pyramid in the development of Egyptian stone cutting and stone finishing techniques deserves attention, because the quality of the stonework at the Red Pyramid represents a significant advance over the quality achieved at earlier pyramid sites. The core blocks of the Red Pyramid are more uniformly sized and more carefully finished than the core blocks of the Bent Pyramid, reflecting the refinement of quarrying and cutting techniques over the intervening period. The casing blocks, the few that survive at the base of the pyramid, are cut with a precision that approaches the precision of the Great Pyramid's casing, with smooth surfaces and tight joints that demonstrate the mastery of stone finishing techniques that the builders had achieved. The specialized stone finishing techniques that the skilled builders used included careful rubbing, the process of smoothing the surface of a cut block by rubbing it with an abrasive material such as sandstone or quartz sand, and polishing, the process of creating a glossy surface by rubbing with progressively finer abrasives until the desired smoothness was achieved. The techniques were labor-intensive. The finishing of a single casing block could require hours of rubbing and polishing, but the results were impressive, producing surfaces that were smooth enough to reflect the sunlight, and that created the gleaming white appearance that the finished pyramid was designed to present. The standardization of block sizes at the Red Pyramid, the use of blocks of approximately uniform dimensions throughout the structure, was a significant advance in construction efficiency that reduced the time and the effort required to fit each block into its position in the growing structure. The standardization was not perfect. The blocks varied in size within a range that reflected the natural variability of the quarrying process, but the variation was smaller than at earlier sites, and the greater uniformity of the blocks allowed the construction to proceed more quickly and with less waste than a construction that used blocks of highly variable dimensions. The development of more efficient methods for leveling and aligning the courses during construction was another technical advance that the Red Pyramid demonstrated. The builders used string lines taut cords stretched between fixed reference points to ensure that each course was straight and level. They used plumb bobs, weighted lines that hung vertically under the influence of gravity, to ensure that the walls of the chambers and passages were truly vertical, and they used measuring rods, standardized lengths of wood or stone that were used to verify the dimensions of blocks and spaces, to ensure that the measurements were consistent and accurate throughout the construction. The combination of these simple but effective measuring tools allowed the builders to achieve a level of geometric precision that was remarkable for the period, and that reflected the accumulated experience of generations of stone builders. Whether Sneferu was satisfied with the Red Pyramid, whether he regarded it as the achievement he had been seeking, or as another compromise, another step on a journey that would never quite reach its destination, is a question that the evidence cannot answer. The evidence shows only that the pyramid was built, that it was completed, and that it served as a functioning funerary complex for generations after the pharaoh's death. The evidence does not reveal the pharaoh's private feelings about the structure, whether he was proud of its achievement or disappointed by its shallower angle, whether he was relieved by its structural success or frustrated by the years of failure that had preceded it. The private feelings of a pharaoh who has been dead for 4,600 years are, unsurprisingly, beyond the reach of archaeology. The sixth exploration examines what the Red Pyramid tells us about the nature of engineering mastery, about what it means to possess sufficient knowledge for a task, and about how the sufficiency of knowledge is demonstrated. The Red Pyramid's construction methods, the specific techniques that the builders used, became the standard for all subsequent pyramid construction, and their establishment at the Red Pyramid was among the most important contributions of Sneferu's building program to the Egyptian tradition. The quarrying involved cutting channels into the limestone bedrock using copper chisels and stone hammers, inserting wooden wedges, soaking them with water to cause expansion and fracture the stone, and levering the freed blocks from the quarry with wooden levers. The technique was labor-intensive but reliable, and had been refined through decades of practice to the level of efficiency needed for the Great Pyramid's even larger construction requirements. The transport involved placing each block on a wooden sledge, wetting the sands ahead to reduce friction, and hauling with rope teams. At the Red Pyramid, the distances were short, but the technique was organized into a continuous flow. Loaded sledges moving constantly from quarry to site, empty sledges returning, maximizing throughput and minimizing idle time. The placement involved raising blocks from ground level using ramps. The specific ramp design at the Red Pyramid is not known with certainty. The ramps were dismantled after construction, but they were almost certainly some form of external ramp system that allowed workers to drag blocks upward on sledges to the level under construction. The finishing involved applying the Tura limestone casing, blocks cut to precise dimensions with smooth exterior faces and angled interior faces mating with the core. The casing was the most technically demanding element, requiring the greatest precision and the most skilled craftsmanship. It was applied bottom up, each course adjusted to the correct angle before the next core course was laid above. The final polishing was done top down as ramps were removed. The Red Pyramid's construction represented a logistical achievement comparable to the Great Pyramid, a sustained multi-year operation requiring the management of multiple supply chains, the organization of thousands of workers, and the maintenance of continuous material flow. The logistical achievement is often overshadowed by the engineering achievement, but it was equally important. The best design is useless without the organizational system to execute it. The funerary complex surrounding the Red Pyramid, the mortuary temple on the eastern face, the causeway to the valley temple at the cultivation edge, established the basic layout that would be elaborated at Giza. The mortuary temple contained an offering hall and subsidiary rooms for specific ritual purposes. The causeway was a covered corridor serving as the ritual pathway from the living world to the dead. The Valley Temple was the point of contact where funeral rituals began. Whether Sneferu was satisfied with the Red Pyramid, whether he regarded it as the achievement he sought or another compromise, is beyond the reach of archaeology. The evidence shows only that the pyramid was built, was completed, and served as a functioning funerary complex for generations. The private feelings of a pharaoh dead for 4,600 years are unsurprisingly beyond recovery. The question of Sneferu's burial location, which of his pyramids actually received his body, remains one of the unresolved questions of 4th Dynasty archaeology. The fragmentary human remains found in the Red Pyramid's burial chamber may be Sneferu's, but the identification is uncertain. Some scholars favor the Red Pyramid as the actual burial site because it was the last and most successful of Sneferu's constructions. Others favor the Bent Pyramid because of its more elaborate internal structure and its closer association with the satellite pyramid and valley temple. The debate reflects the unprecedented character of Sneferu's multiple pyramid building program, a program that left scholars with the unusual problem of determining which of several structures served as the pharaoh's actual tomb. The Red Pyramid demonstrates engineering mastery in the most direct way possible, through the success of the structure. The pyramid stands. It has stood for 4,600 years. It has not cracked. It has not settled. It has not required emergency repairs. It has not failed in any respect that the archaeological evidence reveals. The success is the proof that the builders possessed the knowledge that was needed for the task, that the design was adequate for the loads it was required to bear, and that the execution was competent at every stage of the construction process. But the mastery that the Red Pyramid demonstrates is a specific kind of mastery, the kind that comes from experience rather than from theory, from the correction of errors rather than from the avoidance of them, from the painful process of learning what does not work rather than from the inspired insight that identifies what does. The mastery is not elegant, it is not inspired, it is not the kind of mastery that produces immediate admiration or that lends itself to dramatic narrative. It is the quiet, disciplined, unglamorous mastery of craftsmen who have learned their trade through years of practice and who bring to their work a competence that is so thorough and so reliable that it is almost invisible, noticed only in its absence, valued only when it fails, and taken for granted precisely because it is so consistently successful. Step back now from the construction details and the engineering analysis and the archaeological evidence. Step back from the Red Pyramid as a building and look at it as something else, as a demonstration of a truth about human achievement that the modern world needs to hear. The truth is this: the most important achievements are not the most dramatic ones. They are the ones that work. The Bent Pyramid is dramatic. Its bent profile, its emergency repairs, its visible record of crisis and compromise make it one of the most compelling stories in the history of architecture. The Red Pyramid is not dramatic. Its smooth sides, its consistent angle, its absence of structural distress make it, from a storytelling perspective, almost boring. But the Red Pyramid is the more important structure because it is the one that works, the one that proves the knowledge is sufficient, the one that opens the door to everything that follows. The distinction between the dramatic and the important is one that the modern world consistently confuses. We celebrate the dramatic, the crises, the breakthroughs, the moments of inspiration and desperation that make good stories and good headlines. We undervalue the important, the quiet competence, the reliable execution, the unglamorous application of proven methods that produces results that are consistent, predictable, and sustainable. The Red Pyramid is the ancient embodiment of the important, the structure that demonstrates what happens when knowledge is applied with discipline, and when the lessons of failure are translated into the practices of success. Let that sink in. The Red Pyramid also demonstrates something about the nature of knowledge itself, something about how knowledge is validated and how the sufficiency of knowledge is established. Knowledge is validated not by argument but by application, not by showing that a theory is logically consistent, but by showing that it works in practice, that the design it produces stands up, that the structure it builds does not fail. The Red Pyramid is the validation of the knowledge that the Bent Pyramid's crisis had generated, the physical proof that the lessons were correct, that the revised design was adequate, and that the builder's understanding of the forces and the materials was now sufficient for the task. The validation was not merely technical, it was institutional. The success of the Red Pyramid validated not only the specific design decisions that the builders had made, but the entire process by which those decisions had been generated. The process of experimentation, failure, analysis, and revision that had produced the knowledge over the preceding decades. The validations established the process as reliable, as a method that could be trusted to generate correct answers to engineering questions, that could be applied to new challenges with confidence, and that could be transmitted to subsequent generations of builders as a proven approach to the problems of monumental construction. The establishment of a reliable process, a method that consistently produces correct results and that can be transmitted across generations, is one of the most important achievements that any civilization can accomplish. The achievement is not dramatic. It does not produce headlines or monuments or stories that are told and retold across the centuries, but it is the foundation on which all subsequent achievements are built, because a reliable process is what distinguishes a civilization that can consistently produce great structures from a civilization that occasionally produces them through luck or individual genius. The Red Pyramid established a reliable process for the construction of true pyramids, and the establishment of that process was the most important contribution that Sneferu's building program made to the Egyptian building tradition. This is not science fiction. This is the actual history of one of the most important engineering traditions in human civilization. A tradition that produced the Great Pyramid of Giza, the most impressive stone structure ever built, and that rested on the foundation of the Red Pyramid's demonstrated success. The Great Pyramid was not a leap into the unknown. It was a step taken with confidence, on the firm ground of proven methods and proven knowledge, by builders who knew what they were doing, because the Red Pyramid had shown that their methods worked. Let that sink in. The question of what happened to the knowledge that built the Red Pyramid, the specific, practical, experiential knowledge that the builders had accumulated through decades of experiment and experience, is a question that connects the Red Pyramid's story to the broader theme of institutional knowledge and its vulnerability to loss. The knowledge was transmitted. It passed from the builders of the Red Pyramid to the builders of the Great Pyramid, enabling the next generation to construct the largest and most precise stone structure in the ancient world. But the transmission was not permanent. The knowledge was attenuated over subsequent generations as the scale of pyramid construction declined, as the institutional structures that maintained the knowledge were reorganized, and as the practical experience of the master builders was diluted by the passage of time. The Red Pyramid's relationship to the Great Pyramid, the relationship between the proof of concept and the masterpiece, is one of the most important relationships in the history of architecture, and it is a relationship that deserves to be understood in its full complexity rather than reduced to the simple narrative of supersession that popular accounts tend to provide. The Great Pyramid did not supersede the Red Pyramid, it built on it. The Great Pyramid did not replace the Red Pyramid, it extended it. The relationship was not one of replacement but of development. The Great Pyramid was the next step in a progression that the Red Pyramid had made possible, not a repudiation of what the Red Pyramid had achieved, but an extension of it to a larger scale and a higher level of precision. The specific innovations that the Great Pyramid introduced, the steeper angle of approximately 51 degrees, the larger block size, the more precise alignment, the more elaborate internal structure, with its granite king's chamber and its stress-relieving chambers, were all developments that built on the foundation of the Red Pyramid's proven methods. The Great Pyramid's builders did not start from scratch. They started from the Red Pyramid, from the proven angle, the proven course orientation, the proven foundation preparation, and the proven chamber design that the Red Pyramid had validated. The innovations were extensions, pushes beyond the proven limits, attempts to achieve more than the Red Pyramid had achieved, while maintaining the structural soundness that the Red Pyramid had demonstrated. The willingness to push beyond the proven limits, to attempt a steeper angle, a larger scale, and a more elaborate internal structure than the Red Pyramid had validated. was itself a consequence of the confidence that the Red Pyramid's success had generated. The builders of the Great Pyramid were confident that the true pyramid form was achievable, confident that the construction methods were reliable, and confident that the design parameters could be extended beyond the conservative limits that Sneferu's builders had established. The confidence was justified. The Great Pyramid was completed without structural failure, demonstrating that the extensions were within the range that the materials and the methods could safely support. But the confidence was also risky, because the extensions pushed the technology closer to its limits than the Red Pyramid had done, and the success of the Great Pyramid should not obscure the fact that the extensions involved genuine engineering risk that the builders accepted, because the Red Pyramid had given them reason to believe that the risk was manageable. The attenuation of the knowledge is one of the most sobering aspects of the pyramid building tradition, because it demonstrates that even the most impressive bodies of institutional knowledge are vulnerable to the forces of institutional change and generational turnover. The builders of the Red Pyramid possessed knowledge that was, in practical terms, among the most valuable in the ancient world. The knowledge of how to construct monumental stone structures of extraordinary precision and durability. The knowledge had been gained through decades of painful experience, through collapses and crises and emergency repairs, and the slow, disciplined process of learning from mistakes. And the knowledge was lost, not in a single catastrophic event, but gradually, through the normal processes of institutional evolution that affect every organization and every tradition. The modern study of the Red Pyramid has been advanced by the application of new technologies. Technologies that allow researchers to examine the structure in ways that were not possible for earlier generations of scholars. Photogrammetric surveys, which use photographs taken from multiple angles to create detailed three-dimensional models of the structure, have provided new data about the pyramid's external dimensions, its surface condition, and the remaining casing stones. Laser scanning, which uses laser beams to measure distances with millimeter precision, has provided new data about the internal dimensions of the chambers and passages. Ground-penetrating radar, which uses electromagnetic pulses to detect buried features, has been used to investigate the area around the pyramid for evidence of the construction ramps, the workers' settlement, and other features of the construction infrastructure. The technological investigations have confirmed the general picture that earlier studies had established. The picture of a well-designed, well-constructed structure that was built with a level of competence that reflected the accumulated knowledge of the entire building program. The investigations have also revealed new details about the specific dimensions of individual blocks, about the variations in block size across different parts of the structure, and about the condition of the internal chambers and passages that supplement the observations of earlier researchers. The Red Pyramid's contribution to the modern understanding of ancient Egyptian engineering has been significant, not because the pyramid has yielded dramatic discoveries or unexpected features, but because it has provided the baseline against which other pyramids can be compared. The Red Pyramid is the standard, the first successful true pyramid, the structure against which the innovations of the Great Pyramid can be measured and the failures of the Bent Pyramid can be evaluated. The standard is essential for understanding the development of the pyramid building tradition, because without a standard, the innovations and the failures cannot be assessed in their proper context, and the development of the tradition cannot be traced with the precision that meaningful historical analysis requires. The loss was not inevitable. It was the product of specific decisions about how much to invest in the training of the next generation of builders, about how much to invest in the maintenance of the institutional structures that supported the construction program, and about how much to invest in the documentation and the transmission of the knowledge that the program had generated. The decisions were made by pharaohs and administrators who had other priorities: military campaigns, diplomatic relationships, temple construction, agricultural management, and who allocated resources accordingly. The pyramid building program received progressively less support over the decades and centuries that followed the Fourth Dynasty, and the knowledge that the program had generated was progressively attenuated as the institutional structures that maintained it were progressively weakened. The implications of the Red Pyramid for our understanding of ancient Egyptian society extend beyond engineering and architecture to the broader questions of how the Egyptian state functioned, how its resources were allocated, and how its priorities were determined. The construction of the Red Pyramid, like the construction of every pyramid, was a state project, funded by the state, managed by the state, and executed by a workforce that was recruited, organized, and sustained by the state. The project consumed a significant share of the state's resources: labor, materials, administrative capacity, and economic output, and the allocation of these resources to pyramid construction rather than to other possible uses was a decision that reflected the priorities and the values of the Old Kingdom, political and religious system. The enormous priority given to pyramid construction was not at all arbitrary. It was the logical consequence of the Egyptian religious system's emphasis on the afterlife and on the pharaoh's role as the mediator between the human world and the divine order. The pyramid was the most important structure in the kingdom because the pharaoh's survival in the afterlife was the most important concern of the Egyptian state, and the pyramid was the instrument through which that survival was ensured. The priority was supported by the entire social and political structure of the Old Kingdom, by the priesthood, which provided the theological justification, by the bureaucracy, which managed the execution, by the military, which provided security and logistics, and by the population, which provided the labor and the agricultural surplus that funded the project. The question of whether the population willingly participated in the pyramid building program or whether they were coerced, whether the Corvée labor system was experienced as an honor or as a burden, is a question that the evidence cannot definitively answer. The extensive evidence from the workers' settlements excavated at Giza suggests that the workers were well treated, fed generously, housed adequately, and provided with medical care when they were injured. The evidence from the workers' cemeteries suggests that the workers were respected, buried with care, and with simple funerary provisions that indicate they were valued members of the community. But the evidence does not reveal the workers' own feelings about their participation, whether they regarded the demanding work as a privilege, a solemn duty, an unwelcome burden, or simply as an accepted fact of life that was simply accepted without particular question or complaint. The question of what the Red Pyramid means for our understanding of progress, for our understanding of how civilizations advance, how knowledge accumulates, and how the achievements of one generation enable the achievements of the next, is a question that the pyramid addresses through its existence rather than through any specific feature of its design or construction. The pyramid exists. It stands. It has stood for 4,600 years. And its existence, its continued, structural, 4,600-year existence, is the answer to the question of whether progress is real, whether knowledge actually accumulates, and whether the painful process of learning from failure actually produces results that endure. The answer is yes. Progress is real. Knowledge does accumulate. The process of learning from failure does produce results. And the Red Pyramid is the proof, the physical, permanent, 4,600-year-old proof that the process works, that the knowledge is reliable, and that the results endure. The proof is not dramatic. It is not spectacular. It is not the kind of proof that generates excitement or that captures the imagination of the public. But it is real as the stone from which the pyramid is built, as enduring as the structure that the stone supports, and as reliable as the knowledge that placed the stone in the position where it has remained for 46 centuries. The Red Pyramid's significance for modern engineering education and practice lies in its demonstration of the iterative nature of engineering development. The demonstration that engineering mastery is achieved not through single breakthroughs, but through sustained programs of experimentation, failure analysis, and incremental improvement. The modern engineering profession recognizes the importance of iterative development. The concept is embedded in the design process, in the testing protocols, and in the quality assurance procedures that govern contemporary engineering practice. But the modern profession sometimes forgets the human dimension of the iterative process, the anxiety, the uncertainty, the professional risk, and the personal courage that are required when the iteration involves a real crisis, a real failure, and a real threat to the project and the people who are responsible for it. The Red Pyramid reminds us of this human dimension, because the iteration that produced it was not a comfortable, low-stakes process of incremental improvement, but a high-stakes, high-pressure process of crisis response and adaptive learning that demanded the best of the builder's technical skill, their organizational competence, and their personal courage. The Bent Pyramid taught the lessons. The Red Pyramid applied them. The Great Pyramid perfected them. The sequence is the sequence of engineering mastery, not the instant mastery of the genius who gets it right on the first try, but the earned mastery of the professional who gets it right on the third try, because the first two tries taught the lessons that the third try required. The earned mastery is more valuable than the instant mastery, because the earned mastery is more reliable, more transferable, and more durable. The earned mastery does not depend on individual genius. It depends on institutional knowledge, knowledge that is securely held in the methods and the established practices of the organization, rather than in the mind of any single individual, knowledge that can be reliably transmitted across generations through systematic training and apprenticeship, knowledge that endures and persists even when the individuals who originally created it have long since died. The experience of standing at the base of the Red Pyramid and looking up at its smooth, consistent slope, the slope that rises without interruption from base to apex, without the bend or the step that characterizes its predecessors, is an experience that communicates, more directly than any written description could, the achievement that the pyramid represents. The slope is consistent, the angle is maintained, the surface is unbroken, the geometry is correct. The experience is one of completeness, of a structure that has achieved what it set out to achieve, that has fulfilled its design intent, without compromise, and that stands as the physical demonstration that the goal was achievable and the methods were sound. The Red Pyramid does not ask to be admired. It does not demand attention. It does not compete with the Great Pyramid for fame or with the Bent Pyramid for drama. It simply stands, doing what it was designed to do, being what it was designed to be, the first true pyramid, the proof of concept, the quiet validation of a century of painful learning. The standing is enough. The standing is the message. And the message, that knowledge gained through failure, is real, reliable, and enduring, is a message that the modern world needs to hear as much as the ancient world needed to learn it. The modern parallel is direct and unsettling. The knowledge that maintains the most critical systems of modern civilization, the power grids, the water treatment plants, the transportation networks, the digital infrastructure, is held, like the knowledge that built the Red Pyramid, primarily in the minds of the people who operate and maintain these systems. The knowledge is practical, experiential, and embodied, stored primarily in human minds and skilled human hands rather than in documents or databases. And the knowledge is vulnerable to the retirement and departure of experienced personnel, to the reorganization of institutional structures, to the budget cuts and institutional reorganizations that reduce or eliminate training programs, and to the simple passage of time that erodes the connection between one generation of practitioners and the next. The Red Pyramid stands as a reminder, a physical, visible, 4,600-year-old reminder that knowledge is the most valuable and the most fragile product of human civilization. The stone endures, the knowledge does not. And the gap between the enduring stone and the lost knowledge is the warning that the Red Pyramid carries across the millennia. The warning that building something truly great is only the very beginning, that the knowledge that makes greatness possible must be actively maintained and actively transmitted, and that the failure to actively maintain and transmit the knowledge will inevitably and eventually result in the loss of the capability it supports. The grief moment of the Red Pyramid's story is not dramatic. It is quiet, and it concerns not the pyramid itself, but the man who built it. Sneferu built 3 pyramids. The first collapsed. The second bent. The third was perfect. The sequence is a narrative of persistence, of determination, of the refusal to accept failure as final. Sneferu did not give up after the Meidum collapse. He did not give up after the bent pyramids crisis. He continued, investing more resources, starting more projects, pushing the boundaries of what was possible. Until, finally, on his third attempt, he got it right. The persistence is extraordinary, and it is the quality that defines Sneferu's contribution to the history of architecture. He was not the most talented builder. He was the most persistent. The pharaoh who refused to accept that the true pyramid was impossible, who continued to invest in the experiments that would eventually prove it was not, and who lived long enough to see the proof standing on the desert plateau, smooth and complete, the first true pyramid in the history of the world. The Red Pyramid stands in the desert at Dahshur, patient, massive, and quiet in a way that the bent pyramid, with its dramatic bent profile, is not. The Red Pyramid does not demand attention. It does not tell a dramatic story. It does not invite the kind of speculation and analysis that the bent pyramid's visible crisis provokes. The Red Pyramid simply stands, doing what it was designed to do, being what it was designed to be, demonstrating through its continued existence that the design was correct and that the builder's knowledge was sufficient. The quietness of the Red Pyramid is itself a lesson about the nature of success and the way that success is perceived. Success is quiet, failure is loud. The bent pyramid's failure is visible from kilometers away. The bent profile announces the crisis to every observer, demanding explanation and provoking analysis. The Red Pyramid's success is invisible. Its smooth sides and its consistent angle announce nothing except competence, provoking no questions and demanding no explanations. The asymmetry between the visibility of failure and the invisibility of success is one of the most pervasive features of human experience, and it is an asymmetry that consistently distorts our understanding of achievement, causing us to overvalue the dramatic failures and undervalue the quiet successes that are in fact the more important events. The implications of the Red Pyramid for the modern world extend beyond the specific lessons about engineering and construction to a broader reflection on the relationship between process and outcome, between the unglamorous work of developing reliable methods and the spectacular results that reliable methods produce. The modern world tends to celebrate outcomes, the finished products, the completed projects, the achieved goals that are the visible evidence of human effort and human capability. The modern world tends to undervalue process, the methods, the procedures, the institutional practices that produce the outcomes, and that determine, more than any other factor, whether the outcomes are consistent, reliable, and sustainable. The Red Pyramid reminds us that the process is more important than the outcome, because the process is what produces the outcome, and a reliable process will produce reliable outcomes consistently across multiple projects and multiple generations. The Red Pyramid was the outcome of a process, the process of experimentation, failure, analysis, and revision that Sneferu's building program had sustained over decades. The outcome was impressive, a true pyramid, the first in history. But the process was more impressive because the process, once established, could produce true pyramids again and again at Giza and at every subsequent site where the builders applied the methods that the process had validated. The visitor who comes to Dahshur today encounters a landscape that tells the entire story of the Egyptian pyramid building tradition in miniature. The bent pyramid to the south, with its distinctive bent profile recording the crisis and the compromise that defined the experimental phase, and the Red Pyramid to the north, with its smooth, consistent sides recording the mastery and the confidence that defined the mature phase. The two pyramids stand within sight of each other, close enough that a visitor standing at the base of one can see the other on the horizon, close enough that the contrast between them is immediate and inescapable. The contrast is the story of failure and success, of crisis and resolution, of knowledge gained and knowledge applied. The experience of visiting the Red Pyramid is different from the experience of visiting the Bent Pyramid. and the difference reflects the different characters of the two structures. The bent pyramid is dramatic. Its bent profile draws the eye, invites questions, and provokes analysis. The red pyramid is serene. Its smooth sides and its consistent angle create a sense of calm and of completeness that the bent pyramid's profile does not. The serenity is appropriate, because the red pyramid is a structure that has achieved what it set out to achieve, a building that has fulfilled its design intent without compromise or modification. The serenity is the visual expression of engineering mastery, the quiet confidence of a structure that knows it was built right. The interior of the red pyramid is accessible to visitors, and the experience of descending the narrow entrance passage, of entering the first chamber with its corbelled ceiling, and of climbing the passage to the burial chamber above is one of the most remarkable archaeological experiences available in Egypt. The chambers are empty. The grave goods that were originally placed in them have been removed either by ancient tomb robbers or by later explorers, but the chambers are impressive. Their corbelled ceilings soaring above the visitor's head, their limestone walls smooth and precisely fitted, their proportions creating a sense of space and of height that is both architecturally impressive and spiritually evocative. The chambers are the Red Pyramid's most intimate feature. The spaces where the pharaoh's body was placed, where the funerary rituals were performed, and where the transformation from mortal king to immortal god was believed to begin. The ongoing archaeological and conservation work at Dahshur continues to add to our understanding of the Red Pyramid and its place in the Egyptian building tradition. Recent surveys have provided new data about the pyramid's internal structure, its construction methods, and the condition of its remaining casing stones. The data have confirmed the general picture that earlier studies established. The picture of a well-designed, well-constructed structure that was built with a level of competence and a degree of care that reflected the accumulated knowledge of the entire building program. The data have also revealed new details about the specific techniques that were used for individual courses, about the variations in block size and quality across different parts of the structure, and about the condition of the underground passages and chambers that are not normally accessible to visitors. The conservation work has focused on the stabilization and the preservation of the remaining casing stones. The fragments of the original Tura limestone surface that have survived the centuries of hand stone robbing, and that provide the only direct evidence for the pyramid's original appearance. The casing stones are fragile, exposed to wind erosion, temperature fluctuations, and moisture infiltration that are slowly degrading the stone surface. The conservation involves the application of protective treatments, the repair of damaged areas, and the monitoring of the stone's condition over time to detect and address deterioration before it becomes irreversible. The work is essential because the casing stones are among the most valuable features of the Red Pyramid, providing direct evidence for the construction techniques and the finishing quality that the builders achieved. The Red Pyramid's status as the first true pyramid gives it a significance that transcends the specific details of its construction and its engineering, a significance that connects it to the broadest questions about human achievement, human persistence, and the nature of progress itself. The pyramid is the first structure to achieve the form that would define the most famous monuments of the ancient world, the first proof that the form was achievable, the first demonstration that the methods were reliable. The firstness is the pyramid's most important quality, more important than its size, more important than its precision, more important than any specific technical feature of its design or construction. The firstness also carries a philosophical weight that the subsequent pyramids do not. The Red Pyramid proved something. It proved that a true pyramid could be built. The Great Pyramid extended the proof. It showed that a true pyramid could be built at a larger scale and with greater precision. But the extension is less philosophically significant than the original proof, because the original proof addressed a fundamental question: is it possible? While the extension addressed a comparative question: how much bigger and better can it be done? The fundamental question is the more important question, and the Red Pyramid is the structure that answered it. The answer has been standing on the Dahshur plateau for 4,600 years. Visible to anyone who visits the site, accessible to anyone who descends the entrance passage and enters the chambers, and available for study by anyone who brings to the site the knowledge and the curiosity that the pyramid rewards. The answer is not dramatic, it is not spectacular, it is not the kind of answer that generates headlines or fills museum halls or attracts millions of tourists. The answer is quiet as the competence it demonstrates, as quiet as the knowledge it embodies, as quiet as the success that it represents. But the answer is real, and the reality has endured for 4,600 years, longer than any headline, longer than any museum exhibit, longer than any tourist attraction. The answer endures because it is made of stone, and the stone was placed by builders who knew what they were doing because they had learned, through failure and through crisis and through the painful process of discovering what did not work, exactly what was needed to make it work. The question of why the Red Pyramid is less famous than the Great Pyramid, why a structure of such historical importance receives so much less attention than its more famous successor, is a question that illuminates the biases and the preferences that shape popular understanding of the ancient world. The Great Pyramid is famous for its size. It is the largest pyramid in Egypt, and size is the quality that the popular imagination most readily grasps and most easily remembers. The Red Pyramid is smaller, the third largest pyramid in Egypt, impressive in absolute terms, but less impressive relative to the Great Pyramid. The size difference is the primary reason for the Red Pyramid's relative obscurity. The popular imagination gravitates towards superlatives, and the third largest pyramid is not a superlative that captures the public's attention. But size is not the most important measure of a building's significance, and the Red Pyramid's relative obscurity illustrates the way that the popular focus on size can distort our understanding of historical importance. The Red Pyramid's importance lies not in its size, but in its achievement, its status as the first true pyramid, the first structure to demonstrate that the smooth-sided pyramidal form was achievable, and the first validation of the construction methods that would make the Great Pyramid possible. The achievement is more important than the size because, without the achievement, the size would never have been attempted. The Red Pyramid made the Great Pyramid possible. The Great Pyramid did not make the Red Pyramid possible. The chronological and the causal priority belong to the Red Pyramid, and the popular focus on size inverts this priority, giving the credit to the culmination rather than to the foundation. The Dahshur Plateau, the site of both the Bent Pyramid and the Red Pyramid, is less accessible and less visited than the Giza Plateau, which is located on the outskirts of Cairo, and which is one of the most popular tourist destinations in the world. The relative inaccessibility of Dahshur has contributed to the Red Pyramid's obscurity. Fewer visitors means fewer photographs, fewer travel accounts, fewer documentary films, and less public awareness of the site and its significance. The Egyptian government has made efforts to increase access to Dahshur, improving roads, expanding visitor facilities, and promoting the site as a destination for tourists who wish to experience the history of Egyptian pyramid construction beyond the familiar monuments of Giza. The efforts have been partially successful. Visitor numbers at Dahshur have increased in recent years. But the Red Pyramid remains far less well known than the Great Pyramid, a disparity that reflects the persistent power of size and familiarity in shaping public perception of historical significance. The Red Pyramid is often overlooked in favour of the Great Pyramid, just as the Bent Pyramid is often told as a story of failure rather than a story of learning. The oversight is natural. The Great Pyramid is larger, more famous, and more impressive, and the human tendency to focus on the biggest and the best means that the structures that prepared the way for the biggest and the best are easily forgotten. But the oversight is unjust, because the Red Pyramid was the essential precondition for the Great Pyramid, the structure without which the Great Pyramid could not have been built. The Great Pyramid was built with confidence, the confidence that the true pyramid form was achievable, that the construction methods were reliable, and that the design parameters were within the range that the materials could safely support. That confidence came from the Red Pyramid. It came from the experience of building a true pyramid successfully, without crisis, without emergency repairs, and without the need to compromise the design. The Red Pyramid gave the builders of the Great Pyramid the one thing they needed most: the certainty that what they were attempting was possible. And that certainty was worth more than any individual innovation, more than any specific technical breakthrough, more than any single lesson that the earlier experiments had produced. The Red Pyramid stands on the desert plateau at Dahshur, the third tallest pyramid in Egypt, the first true pyramid in human history, and the most important building that almost nobody talks about. It is important not because of what it is, but because of what it made possible. The Great Pyramid of Giza, the most impressive stone structure ever built, was built on the foundation of the Red Pyramid's demonstrated success. The Great Pyramid was built by builders who knew that what they were attempting was achievable, and they knew because the Red Pyramid had shown them. The pyramid is reddish in the afternoon light, the iron oxide-tinted limestone of its core giving it the warm colour that earned it its modern name. The original casing is gone. The fine white Tura limestone that once covered the entire surface has been stripped away by centuries of stone robbing, exposing the rougher, redder core blocks beneath. The removal of the casing has changed the pyramid's appearance. It is rougher, darker, and less geometrically perfect than it would have been in its original state. But the structure beneath the casing is sound. As sound today as it was 4,600 years ago, the blocks still bearing the loads they were designed to bear, the foundations still supporting the weight they were designed to support, the chambers still standing open and intact beneath the mass of stone above. Somewhere inside the pyramid, in the burial chamber, accessible through the passages that descend from the north face, human bones were found. They may be Sneferu's. They may be someone else's. The identification is uncertain. A final mystery in the story of a pharaoh who built more pyramids than any other king in Egyptian history and whose final resting place has never been conclusively determined. If the bones are Sneferu's, then the pharaoh who refused to accept failure, who built pyramid after pyramid until he got it right, lies inside the structure that was his vindication, the first true pyramid, the proof that his persistence was justified. The pharaoh who built the Red Pyramid, Sneferu, the founder of the 4th dynasty, the most prolific pyramid builder in Egyptian history, is remembered as the pharaoh who got it right. Not on the first try, not on the second try, on the third try. The persistence is the story. The refusal to accept failure as final. The determination to continue investing in experiments that had not yet produced the desired result, and the faith that the knowledge would eventually be sufficient for the task. The faith was justified. The Red Pyramid was the justification, and the justification has been standing on the Dahshur plateau for 4,600 years. Patient, quiet, and undramatic, but present, enduring, and irrefutable. The Red Pyramid does not need to be dramatic. It does not need to tell a story of crisis and compromise. It does not need to bend or crack or require emergency repairs to be important. It needs only to stand, smooth, complete, structurally sound, as the permanent physical, archaeological proof that the process of learning from failure actually works, that the knowledge gained through painful and costly experience is genuinely real and genuinely reliable, and that the application of hard-won knowledge to new challenges can produce results that endure not merely for decades or centuries, but for millennia. Sneferu's building program moved more stone than any other pharaoh's. It cost more resources, employed more workers, and consumed more years of concentrated effort than any other construction program in Old Kingdom history. The program produced a collapse, a crisis, and a compromise before it produced a success. The sequence was not efficient, it was not elegant. It was not the kind of streamlined, optimized process that a modern project manager would approve, but sequence was effective. It produced, through the painful process of trial and error, the knowledge and the methods that made the Great Pyramid possible. The Red Pyramid was the culmination of the sequence, the structure that demonstrated that the knowledge was sufficient and that the methods were reliable. The Red Pyramid is the answer. Not the answer to a single question, but the answer to the question that the entire pyramid building tradition had been asking for a century. The question of whether it was possible to build a true pyramid, a smooth-sided structure of monumental scale, using the materials and the methods available to the Old Kingdom Egyptian builders. The answer is yes, and the Red Pyramid is the proof. The proof has been standing on the Dahshur Plateau for 4,600 years. It has survived earthquakes, sandstorms, and the systematic removal of its casing stones. It has survived the fall of the Old Kingdom, the chaos of the intermediate periods, the glory of the New Kingdom, and the conquest of Egypt by every foreign power from the Persians to the British. It has survived because it was built correctly, because the angle was right, the foundation was sound, the courses were level, and the chambers were proportioned to withstand the loads that the structure imposed. The pyramid has survived because the builders knew what they were doing, and they knew because they had learned, through failure, through crisis, through the painful process of discovering what did not work and then figuring out what did. The lesson of the Red Pyramid is the lesson that every builder, every engineer, every organization, and every civilization needs to learn. The lesson that success is built on the foundation of failure, that knowledge is gained through the correction of errors, and that the most reliable methods are the methods that have been tested by experience and refined by the painful process of discovering what does not work. The Red Pyramid embodies this lesson, not in dramatic fashion, not with the visible scars of crisis and compromise that the bent pyramid displays, but quietly, competently, and with the serene confidence of a structure that was built by people who knew exactly what they were doing, because they had already learned, at terrible cost, what not to do. The pyramid stands. It has stood for 4,600 years. It will, if the forces of nature and human behavior permit, stand for 4,600 more, and for as long as it stands, it will carry its message. The message that the first true pyramid was built not by genius but by experience, not by inspiration but by application, not by avoiding failure but by learning from it. The message is written in stone, and the stone endures. The sequence is complete. The step pyramid showed that monumental stone construction was possible. The Meidum pyramid showed that converting a step pyramid to a true pyramid was dangerous. The bent pyramid showed that building a true pyramid at a steep angle was beyond the current state of knowledge, and it showed, through the crisis and the compromise that followed, what the limits of the current knowledge actually were. The Red Pyramid showed that building within those limits produced a structure that worked, a true pyramid, smooth-sided, geometrically consistent, structurally sound, standing firm after 4,600 years without the cracks, the settlement, or the emergency repairs that had defined its predecessor. The tradition that the Red Pyramid established, the tradition of true pyramid construction, built with horizontal courses, at a moderate angle, on a carefully prepared foundation, was the tradition that Khufu inherited and that he would push, with his father's confidence and his father's determination, to its ultimate expression at Giza. The Great Pyramid was built on the Red Pyramid's foundation, not physically but intellectually, organizationally, and institutionally. The knowledge was there, the methods were proven, the confidence was justified, and the result, the largest, most precise, most enduring stone structure in the history of the world, was the culmination of a tradition that began with Imhotep's first block of limestone at Saqqara, and that reached its maturity, its vindication, and its proof of concept at the Red Pyramid of Dahshur. The desert wind blows across the Dahshur Plateau, the sand gathers at the base of the Red Pyramid, the afternoon light catches the reddish limestone of the exposed core blocks, the warm colour that gives the pyramid its modern name glowing against the pale sand of the surrounding desert. The pyramid stands, smooth, complete, undramatic, the first true pyramid in human history, the proof that was needed, the foundation on which everything else was built. 2 kilometers to the south, the bent pyramid stands in counterpoint, its distinctive bent profile recording the crisis that the Red Pyramid resolved, the lesson that the Red Pyramid applied, the failure that the Red Pyramid redeemed. The two pyramids face each other across the desert, the failure and the success, the question and the answer, the lesson and the application. a dialogue in stone that has been continuing for 4,600 years, and that will continue for as long as the structures stand. The answer to the question posed by the title of this episode, what is the first true smooth-sided pyramid, is the Red Pyramid of Dahshur, built by Sneferu, designed by engineers who had learned their craft through failure, constructed by workers who had earned their competence through experience, standing on the Dahshur Plateau for 4,600 years. Standing still. The bent pyramid, 2 kilometers to the south, taught the lessons. The Red Pyramid applied them. The Great Pyramid, a generation later at Giza, perfected them. The sequence is complete, the tradition is established, and the pyramid that made it all possible, the quiet, competent, undramatic Red Pyramid, stands in the desert, doing what it has always done, being what it has always been, the first true pyramid, the proof that it was possible, the foundation on which everything else was built.